Hi everyone, welcome to goclasses. In this lecture, we will study liveness analysis or live variable analysis. Let me tell you, this liveness analysis or live variable analysis, this is basically an analysis that we do. Analysis means we do the analysis of the source program to get some insights about the source program. Okay, and let me tell you, based on this analysis, there are some optimizations that we can perform, or I can say there are some applications of this analysis. So these are the two important applications of live variable analysis. These are dead code elimination and also register allocation. Okay, so in this lecture, we need to study what is this live variable analysis. In the next lecture, we will study these applications of live variable analysis. Okay. Before we study this live variable analysis, in short, we will call it LVA. Okay. In short, we are going to call it LVA, live variable analysis. So before we study this live variable analysis, let me do some recap of the previous lecture. Let me tell you, if you did not watch the previous lectures, then also do not worry, because all the concepts required in this lecture from the previous lectures, all the concepts that are required, I will do the revision of those required concepts in this lecture. Okay, so this lecture is kind of a self sufficient, or I can say closed lecture. Okay, everything is present in this lecture. Okay, so let's do the recap of some of the concepts that we have seen in the previous lecture. I will put the link of the previous lecture in the description, also in the pinned comment. You can watch it after this lecture or before this lecture. Okay. So let's see some intermediate representation terminology. In the previous lecture, I told you that when we discuss compiler design techniques, or when we discuss the compiler design phases, particularly optimization and intermediate representation, then some terminology we use. And this is the terminology you can see: assignment to a variable, that will also be called definition. So remember, every assignment is also called definition of that variable. Assignment, definition, these are same. In short, we will call it def, or basically this is basically the write operation. Okay, also remember the read operation. When we read a variable in some instruction, when we read a variable, we will also call it use of that variable. We will also call it reference, we are referencing that variable. In short, we will call it read or ref. Okay, so most of the time we will use this word use, and most of the time we will use this word def. Okay, so these are the words that most of the time we are going to use. For example, consider this statement n. So this is the instruction z. In z we are assigning x plus y. So in this instruction, in this statement, what are the variables that we are defining and what are the variables that we are using? So let's see what is the use of n, means what are the variables that we are using in this statement n. So you can see we are using x comma y. Remember, use means read. We are reading x comma y. We are not changing x, we are not changing y, we are just reading them, we are just referencing them. Okay, so remember, in this statement n we are using x comma y. So this is use of this statement n. Okay, also what is the def of statement n? Def set, definition set of this statement n, means which variables we are writing in this statement n. So you can see assignment and definition both are the same thing. We are assigning x plus y to variable z. So basically we are assigning to z. So remember, the definition set of this statement n, which variables we are defining, that is simply z. Variable z we are defining. Okay, so you can see this screenshot here from the Harvard University. Use and definitions. Okay, you can see every instruction or statement uses some variable. Use means read from them. Okay, so remember, when I say we are using some variable, it simply means we are reading from those variables. And when I say that an instruction is defining some variable, then it means the instruction is writing to them. Okay, so you can see for a statement n, for a statement s, what is use of s? This is the set of variables used by s. And what is def of s? That is set of variables defined by s. For example, in this statement, here you can see we are using b comma c, and we are writing, or I can say we are defining a. Consider this statement. Here we are using a and we are defining a. So you can see use, we are using also a, also we are defining a. Very simple. You can read this slide also. You can see what is def of s. This is basically the set of all variables defined by the statement s. Okay, and remember, you can see when we are defining a variable, it simply means we are assigning to that variable. Okay, so you can see LHS variable in assignment statement. LHS in assignment statement, the LHS variable, that is basically the variable to which we are assigning, or I can say that is the variable that we are defining. Okay, you can see use of S. This is the set of variables used by statement S. In assignment statement, it will be present on the RHS. The variables present on the RHS in a assignment statement, these are the variables that we are reading, or I can say we are using. Okay, so you can see what is ref. I told you ref means use, means read. And what is def? That means assignment, or I can say write operation. So you can see that for this instruction, in this instruction we are not using any variable, but we are writing to variable x. I can say we are defining variable x. So you can see the definition set of this statement, that is basically variable x. Okay, and you can see the use set of this statement means which variables we are using. We are not using any variable, so that is empty. Okay, you can see in this statement print x, we are reading x, we are not writing to x. Okay, so you can see we are using the variable x, but we are not writing to any variable. So I can say the def, that is basically empty set. Okay, you can see in this statement we are using x comma y, and you can see we are defining x. Okay, we are defining x and we are using x comma y. Okay, so these terminology we have already seen in the previous lecture also, but we have done the recap. We have done the revision of this terminology. So you can see an instruction x equal to y hashtag z. Sorry, this is the hash, means this is some binary operation. Okay, so you can see this instruction will define x and it will use y comma z. Very simple. Now let's see this definition, dead code definition, or I can say dead assignment. This definition also we have seen in the previous lecture, but let me do the revision, let me do the recap of this definition. So you can see what is a dead code. Let me tell you, I told you in the previous lecture also that dead code, the better word is dead assignment. Okay, now let's see the definition. An assignment to a variable v is called dead. Focus on this. An assignment to a variable v, this assignment will be called dead if the value of this assignment is never used anywhere. Then we will say that this assignment is dead. And remember, in the dead code elimination, we remove this type of assignments. Basically, we find what are the dead assignments. Dead assignment means those assignments whose value is never read anywhere. Such assignments are called dead assignments, and in the dead code elimination, we remove dead assignments from the intermediate representation. Okay, so let me tell you, let me make a diagram to understand what is dead assignment. So, dead code, the better word is dead assignment. So, consider assignment, consider this assignment x. In this x, we are assigning something. Okay, so you can see this x is on the LHS of this assignment statement. We are assigning something to the variable x. Okay, now remember this assignment, when can I say this assignment will be dead? This assignment is dead if this assignment is never used anywhere. Okay, so let's assume that there is no path where this assignment is used. Okay, so let's assume on this path also this x is not used. Which x? This assignment x. Okay, we are talking about this assignment x. So you can see we are talking about this assignment x, that this assignment x, this is not used. Let's assume this is never used. This assignment is never used. Okay, so if this assignment is never used, then in this situation we will say that this assignment is a dead assignment. Okay, we will call it dead code, or you can call it dead assignment. And this type of dead code or dead assignment we can remove from our intermediate representation without any side effects, or I can say without any tension. Okay, now consider this example. We have 4 instructions here. You can see first we will execute this instruction, then the next instruction, and so on. Now you can see these are the 4 assignments. Here you can see we are assigning x value 1. Here we are assigning x. Here also we are assigning x. Here also we are assigning x. Okay, so tell me which of these assignments is dead? You can see that this assignment is dead. Why this assignment is dead? Here we are assigning value 1 to x, but this assignment we are never going to use. Yes or no? Notice one thing, that here we are not using x, here also we are defining x, here also we are assigning x, but we are not using x. Okay, yes or no? Here not using x. Use means read. Okay, so please understand, here we are not using x, we are basically assigning x. Okay, so you can notice that this assignment will never be used anywhere. Similarly, you can see this assignment will never be used anywhere, because in this you can see we are assigning value 2 to x. Okay, this assignment, but in the next instruction we are assigning this value 3 to x. So you can notice this assignment is never going to be used anywhere. Okay, you can see similarly this is also dead, because this particular assignment, this will never be used anywhere. Use means read. Okay, remember, again I am telling you, use means read. Okay, and assign means definition. Okay, so very simple. What about the last assignment? What about this assignment? For this assignment we cannot say it is dead. What is the reason? Maybe in the remaining program, maybe it is used somewhere. Yes or no? Maybe somewhere it is used something like this. Okay, there might be a situation like this. So you can see that maybe somewhere this assignment might be used. So we cannot say it is dead. Okay, but the point is that these three assignments, these are dead, because these assignments will never be used anywhere. You can notice here in this statement we are using x comma z. Okay, remember in this statement we are not using y. Okay, here you can see in this statement we are using x comma z, and remember we are not using y. Okay, understood? Very simple. So you can see dead code elimination will remove statements that are no longer needed. You can see that these three statements are no longer needed, because these assignments will never be used anywhere. In future, if you are going to use this variable x, then this assignment will be used, but these assignments will never be used. So this type of assignments are called dead assignment or dead code, and you can remove them from your intermediate representation. Consider this example. Here also you can see we have simple arithmetic instructions. These are not branch instructions. Okay, none of them is a branch instruction, none of them is a go to instruction. So you can see that the execution will take place in this order. First we will execute this instruction, then instruction 2, 3, 4, and so on. Okay, so very simple. Now you tell me, in this code you focus on this assignment. Here you can see we are assigning x. Remember, here this assignment are we going to use anywhere? You can see after the instruction 1, instruction 2 will execute, then 3 will execute, then 4, then 5. In this order the instructions will be executing, because these are simple arithmetic instructions. None of them is a go to instruction, none of them is a jump instruction. So you can see, look at this assignment and tell me, this assignment, will it ever be used anywhere? You can notice, are we using x here? No, we are not using x here. Okay, here also you can notice that we are not using x, because use means read. So here you can notice we are not using x. Okay, here we are writing x. Okay, so this is another assignment of x. Okay, here also you can see that we are assigning to x. We are not using x, we are assigning to x. Okay, but you can notice that here we are using x. So can I say this assignment we are using here? You can notice that here we are using x. But which assignment we are using? We are using variable x. We are not using variable z. In this last statement we are not using z. Okay, so you can notice here this assignment will never be used, because here we are using x, but this x will be used. I can say that this assignment will be used here. Okay, so I can say that this is like def. Okay, this is the definition and this is the use, but you can see that this assignment will never be used. This assignment, this is never used assignment. So because this is never used assignment, so this is a dead assignment, you can remove it. Very simple. What about the next? What about this assignment? Next is assignment. Tell me, we are assigning to y. This assignment, will it ever be used? This assignment, yes, it is used here. Okay, so I can say this is not a dead assignment. What about the next? You can see this assignment is also used here. we are using this x here. Okay, what about this one? This assignment, you can see here you are assigning z. This assignment, will it ever be used? No, it will never be used, because in the next instruction again you are assigning to z. So again here I can say that this assignment also, I can say it is never used assignment. Okay, very simple. What about the last assignment? Maybe it might be used somewhere, I don't know. Okay, so you cannot say it is dead, because maybe after some time, maybe somewhere in the future program, you can see maybe this z might be used somewhere. Okay, some this type of situation might be there, I don't know. So the point is that for the last instruction you cannot say that it is a dead assignment. Okay, but the point is that these two instructions you can remove, these are dead assignment or dead code, so you can see we can remove them. Okay, you can see that we need to know whether the values assigned to x at the instruction 1, they will never be used later. Okay, very simple. I hope you understood. So we have seen the definition of dead assignment, or I can say dead code. Okay, now let's see some more terminology for intermediate representation optimization. When we study the concept of optimization, IR optimization, this terminology we are going to use. This is program points. We will use this word many times. Program points. In a program, what is a point? Basically, what is a point in a program? So the definition you can read here, that point in a program, what is a point in a program? Point in a program refers to a place within the program's control flow graph where the liveness of a variable will be evaluated. Means in the control flow graph, the places where we are going to find out the liveness of variables, which variables are live, which variables are dead. So which are the places where the liveness of variables will be evaluated? These are called points in a program. And let me tell you, there are four types of program points. You can see just before an instruction, just after an instruction, at the entry to the basic block, at the exit from a basic block. Let's understand this. Basically, in a program, when we study optimization, the concept of code optimization, IR optimization, then remember what are points in a program, or I can say what are program points. Very simple. For every instruction, there are 2 points. Let me tell you. Consider this instruction. Let's assume this is our instruction I. This is the instruction I. So let me tell you that for this instruction, there will be 2 program points. One will be immediately before this instruction, and one will be immediately after this instruction. Okay. So these are the 2 program points, immediately before the instruction, immediately after this instruction. Okay. Remember, on this instruction, there is no program point. Like you cannot say that here there is a program point. No, there is no program point here. There are 2 program points for every instruction. There are 2 program points. One is immediately before the instruction, and one is immediately after this instruction. Okay, is this clear? So you can see, I can say this is a point. Okay, you can say this is the point before I. This is the point before I, and you can say this is the point after I. Very simple. So there are 2 program points because of every instruction. Very simple. And you can see that for every basic block also, there are 2 program points. Let's assume this is the basic block. This is the basic block B. So for this basic block also, there are 2 program points. One is on the entry to this basic block. Okay, is this clear? One is on the entry to the basic block. One is on the exit from this basic block. Okay, is this clear? So remember, there are 2 program points. One program point is here, that is before basic block B, and one is after basic block B. Okay, so that's it. There are 4 types of program point, nothing else. That's it. Okay, is this clear? So remember, when I say point in a program, then in your mind it should come that either it is immediately before the instruction, or immediately after the instruction, or immediately before the basic block, or immediately after the basic block. Okay, so you can see there are four types of program points: just before an instruction, just after an instruction, at the entry to a basic block, at the exit from the basic block. Okay, understood this point? Let me know. So you can see this here, that point. What is a point in a program? You can see this is a place in the program. For example, if you have a statement S, then there will be two program points. One is before this statement and one is after this statement. And remember, for the basic block also there are two program points. One is before this basic block and one is after this basic block. Okay, so you can see from this diagram, you have this instruction. So there is a program point just before this instruction, and there is a program point just after this instruction. Okay, consider this CFG, this control flow graph. So in this control flow graph, can you tell me how many program points are there? Or I can say, can you tell me some of the program points can you find out? So you can notice that for every instruction, there is a program point just before this instruction, just after this instruction. Similarly, for this instruction also, just before this instruction, that is this. Okay, you can see for this instruction, the after point, and for this instruction, the before point, these are basically same because these are consecutive instructions. Okay, yes or no? So you can notice that for this instruction, there is a program point here. Okay, you can notice that for this instruction, because this is the last instruction of this basic block, so this for this instruction, the after program point will be same as program point after this basic block. Yes or no? Okay, so there is program point here. There is program point here, which is in the beginning of this basic block, or I can say that in the beginning of this instruction. Okay, there is a program point here. There is a program point here. There is a program point here. Program point here. There is a program point. Okay, like this. So you can understand. You understood this. Is this clear? So can you notice that program points are on the edges, I can say. Okay, you can see on the edges you have program points. All the program points you have on the edges. For example, for this instruction, there is a program point just before this instruction, also just after this instruction. So can I say all the program points, these are basically on the edges? For example, consider these two instructions. So you can assume that there is an edge like this. Okay, this is not an edge of the control flow graph, because in the control flow graph, the edges are between the basic blocks. But you can imagine, you can treat that, okay, these are consecutive instructions. So I can say after this instruction, we will execute this instruction. So you can see that this program point is on the edge from this instruction to this instruction. Is this point clear? All the program points, these are basically on the edges. And remember, on the program points, we evaluate the liveness analysis. The liveness information we capture, or we calculate, or we evaluate on the program points. And all the program points, these are basically on the edges. I hope you understood. So you can see program points. There are two program points for each instruction, before instruction and after instruction. So you can see if this is your instruction, then there is a program point before this instruction, there is a point after this instruction. Remember, it is, what is a program point? It is just a place where we are going to evaluate the liveness information. Okay, very simple. And one more thing you can easily notice, that in the basic block, you can have many instructions. You can have, for example, let's assume this is the first instruction. Okay, then you have instruction like this, and let's assume this is the last instruction. Okay, this is the last instruction, and let's assume this is the first instruction. So I can say this is the last instruction of basic block B. Okay, so let's assume this is our basic block B. And similarly, you can notice that this is the first instruction of block B. Okay, so just tell me a simple point, that I told you that before this basic block, there is a program point. After this basic block, there is a program point. So tell me, and you can see for this instruction also, there is a program point before this instruction, and there is a program point after this instruction. and for this instruction there is a program point before this instruction, after this instruction. So can you tell me, and you can easily see here that for the first instruction of the basic block, the program point before this instruction is same as the program point before this basic block, yes or no? Okay, so you can notice that I can say that this is basically, this is the program point before this instruction also, this is the program point before the basic block also. Okay, so you can see that I can say this is the program point before B, at the entry of B, okay, before B, and this is same as program point before the first instruction of this basic block. Okay, and you can see here that this is the program point at the end of B, yes or no? So you can see this is the program point after B, okay, at the end of B, after B, and this is same as program point after IL, because this is the last instruction of the basic block. I hope you understood this point. Okay, and one more thing you can easily notice, let's assume this is instruction IN and this is the instruction IN plus 1. Okay, now you can see that this program point, look at this program point. So this program point is after IN, also this program point is before IN plus 1. Okay, so you can easily see, okay, let me just write it here, that for this program point also you can notice that this is the point, this is the program point, I can say, or in short we will just call it point. Okay, we will simply call it point. So basically this is the program point after IN, and also this is the program point before IN plus 1. Okay, this is the program point before IN plus 1. Okay, that's it. I hope you understood all these points. Simple points. Just visualize them. There is nothing hard here. Okay, simple definitions. You can see in a basic block, the program point after an instruction, that will be same as the program point before the successor instruction. Okay, simple point. So I hope you understood all these concepts. So far, the concepts that we have seen. Now, we have already seen the definition of dead code, or I can say dead assignment. Dead assignment is an assignment which is never used anywhere. Okay, the value of this dead assignment is never used anywhere. This type of assignment is called dead assignment, and you can remove them. This type of dead assignments you can remove from the intermediate representation. Now we need to study, when can I say a variable is live? So let's see the definition of live variable. So far we have seen the definition of dead assignment or dead code. Now we will see the definition of live variable. At a program point, which variables are live, which variables are dead? So let's discuss this. So what is the definition of live variable at a point in program, at some program point? When can I say that a variable is live or a variable is dead? The definition is very simple. A variable is live at a program point if later in the program its value will be read before it is written again, before it is rewritten. So very simple definition. With example, this will become more easy. So you can see, when can I say a variable is live at a program point? You are standing at some program point. A variable will be live at that program point if later in the program its value will be read before it is written again. Let me tell you, you read this definition here. In the live variable analysis, you can see, in the live variable analysis, we wish to know for a variable x at program point P, whether the value of x at P, read this, the value of x at that program point P, whether this value will be, could be used along some path, along some path in the flow graph starting from P. If there is some path, you are standing at a program point P, at that point you want to find out whether the variable x is live or not. So you can see, if the value of x at p, if that could be used along some path, at least one path starting from p, if the value of x can be used, then we will say that x is live at p, otherwise x is dead at p. Very simple. Okay, so you can basically understand this definition. A variable is live at a program point if later in the program its value will be read before it is written again. Let's make a diagram to visualize this. So you can see, let's assume you are standing at a program point p. Okay, there is this program point p. I told you, when I say program point p, it means it is either immediately before some instruction or immediately after some instruction or immediately before a basic block or immediately after a basic block. Yes or no? These are the program points. So you can see, let's assume you are standing at a program point p, and at this program point p you want to figure out whether variable x is live or not. So let me tell you, the definition is very simple. Starting from this program point p, is there some path, is there at least one path, there can be many paths, yes or no? So you can see, is there at least one path, is there at least one path where this variable x will be used, where this variable x will be used, where we are going to use this variable x without writing before using it. Okay, means here you can see that on this, here you are not writing x, here you are not writing x. Okay, and basically starting from this program point p, on this path you are not writing x and you are using x. Maybe after that you can write x, I don't care. But the point is that when you are standing here and you want to check whether x is live or not at this point p, then you start from this point p and you figure out, is there some path where the value of x at this point will be used. Okay, so you can see this variable will be used before being written again. Okay, so remember one thing, on the remaining path it might be written I don't care, there must be at least one path where the value of x at that program point p will be used. Okay, so this type of situation must happen. Maybe on the other path, maybe here, maybe this is we are writing, maybe we are writing x. Okay, maybe here we are not writing, not reading x, maybe here there is no x. Okay, but the point is, there should be at least one path where the value of x is used, and which value, the value which is present at the program point p, that value is used before we write it again. Okay, very simple. I hope you understood this point. So there should be this type of at least one path. With example this will become very clear. So let's see the definition again. A variable v is live at a point p if there is a path from p, starting from p, to exit. There is some path which contains a statement that will use v, and there is no definition of v on this path from p to s. Okay, very simple. You can see a single path is enough. We don't need that on all the path this variable v is used. No, we just need some path, at least one path. So you can see a single path with use of this variable v, that is enough to say that this variable is live at program point p. Okay, you can see a variable that is not live, that is called dead. Let me tell you, you can understand like this, that you are standing on the program point p, this is your program point p, and you are standing here with a binocular. Okay, let's assume you are looking in the future. Okay, you are looking at all the path. Okay, you are looking at all the path. If there is at least one path where you see that the use of variable x happens before we write it again, means here, okay, here there is no write of x. Okay, here there is no write of x. Then in this situation we don't care about the remaining paths. In this situation we will say that at this point p, x is live. I can say x is alive, means x is not dead, x is alive. Okay, I hope this point is clear. So at this point p, we will say that x is alive, or I can say x is live. Let me tell you about the pronunciation. See, actually the correct pronunciation, I think, that will be live. That x is live. or I can say x is alive. Okay, but we will just keep calling it live. Okay, because that is what has stuck to me. Okay, I hope you understood. So don't worry about the pronunciation. Basically, it's like dead or alive, dead or alive, but we will call it live. Okay, don't worry about the pronunciation. Now, so did you understand this definition? Very simple. Consider this diagram. You have three program points. Okay, you can see these are the three program points. Tell me at which program point variable v is live. Variable v is alive. Tell me about the variable v. Assume that the remaining statements do not read or write the variable v. You can see, consider this diagram. In this diagram, here you have remaining statements, but the remaining statements they do not contain v. They do not read, they do not write v. Okay, means this will write v, this will read v. Yes or no? Here we are writing v, here we are writing v. The remaining statements they do not contain v. Here we are writing v also, we are reading v also. Okay, so you tell me at this program point P is variable V alive? At this program point P is variable V alive? Also at this program point P is the variable V alive? What do you think? So basically you are standing here, remember, at the program point P you are standing. Okay, now you can see I am checking for V. So what I will find? I want to find is there a path along that path the variable V is used before it is written again. So you can see that, notice one thing, on this path actually v is written, but I don't care about this path. I just want at least one path where the variable v will be used before it is written again. So here you can see that standing at this point P, you can see on this path, you can notice on this path this variable v we are using. Okay, so I can say at this point I can say that v is alive. Now tell me about this. Here you can see you are standing here. Now tell me, is there any path starting from P? Starting from P, is there any path where variable V is used? You can see here V is not used. Here it is, this is the definition. Here also this is the definition. So you can see that there is no path where V is used. On this path, there is no V. On this path, you can see we are assigning to V. On this path also we are assigning to V. So you can see that there is no path starting from P, there is no path where V will be used before it is assigned again. So very simple point that here I can say that V is dead. Not alive means dead. Okay. And what about this? You are standing at this program point P. Okay. On this path, there is no V. On this path also there is no V. Tell me, here we are reading V, here also we are defining V. Okay, notice here. Here we are using also, here we are assigning also. Okay, so tell me, can I say at this program point P, variable V is alive? You are standing at P. Now, starting from P, is there any path where the variable V will be used before it is assigned again? So let me know. Will you consider this as use before assignment? Yes, this is use before assignment. See, before you assign, you will actually use V. You will calculate V plus 2. So first you will use V, then you will assign to V. So please understand, starting from this program point P, you can notice that we are using variable V before we are assigning it. In this single instruction, we are using V, we are defining V. We are using V, we are assigning V. But remember, before assigning, we are using. Do you agree with me? Very simple point I'm asking, that when you see this statement X, or I can say V equal to V plus 2, then can you notice first what is happening? First we are assigning or we are using. So you can notice that here first we use. Yes or no? First we use V. first we use v, okay, then we assign v. Okay, actually you can understand like this. I can say that you can understand like this. So you can imagine this operation. You can imagine that, okay, first you are using v, okay, you are calculating v plus 2, and then you are assigning to v. Okay, I hope you understood this point. So remember here, first use happens, then assign happens. Okay, here also I can say first use happens, then assign happens. Okay, so let's come back to this point. So you can see that I want to check whether at this program point p v is alive or dead. So you can see that on this path you can notice we are using v before assigning it. Okay, and that's what we want, that from this program point p, starting from this program point p, there should be at least one path, there should be some path where the variable v will be used before it is assigned again. Okay, so yes, that is happening. So I can say at this program point p, I can say v is alive. I hope you understood this point. Okay, so finally you can see here v is v is live at p, v is not live at p, v is live at p. Okay, understood. So we have seen the definition of live variable at a program point p. So you can see a variable v is live at a point p in the control flow graph if there is some path. You can see there is a path, means there is at least one path, there is some path starting from p to a use of v along which v is not redefined. Okay, before using it we are not reassigning it. Very simple. So there should be at least one such path starting from p, then we will say that at program point p this v is alive. Okay, consider these two examples. You can notice, tell me at this program point, like assume that this is the program point, is I am standing here. Okay, tell me, is this assignment used? Can I say this is a dead assignment or not? Consider these two examples. In this example, you just tell me whether this assignment is this dead assignment or not. Just check whether this assignment is this dead assignment or not. This assignment is not dead assignment because this assignment we are going to use here. So this assignment is not dead assignment. Okay, so I can say that this assignment is not a dead assignment. I can say this is not a dead assignment. Okay, and what about this assignment? Is this a dead assignment or not? You can see yes, this is a dead assignment because here we are using x, but before that we are already assigning to x. So remember, actually this x we will use here. Okay, yes or no? So very simple point, that this assignment is basically dead. I can say this is a dead assignment. And we have already seen the definition of dead assignment. An assignment to a variable x is dead if the value of that assignment is never used. So you can see the value of this assignment will never be used. Here we are using x, but we are using this x. Okay, because you can see after this assignment we have again assigned x. Okay, so when we use x here, return x, then we are using this assignment, not this assignment. I hope you understood. So the definition of live variable, dead variable we have already seen. A variable v is live at point p if v is used along some path starting at p and there is no definition of v along that path before the use. Before the use, we are not again defining this variable v. Okay, very simple. And when can I say that a variable v is dead at a point p? Not live means dead, not alive means dead. So you can see that at program point P, V is dead when there is no path where we are using V before defining it. Okay, yes or no? I can say that on all the path we redefine V before using it, or there is no use of V on any path starting from P. Okay, very simple. Consider this example, consider this program, and you can see here these are the program points. I told you what are the program points. For every instruction there are two program points, just before the instruction, just after the instruction. Okay, so here you can see that these are the program points. Okay, now also this is a program point at the end of this instruction. Here also there is a program point. Okay, now the question is asking that you find at every program point you find which variables are alive and which variables are dead. And this is an interesting question. The question is saying that you represent the liveness information using a bit vector. For every variable you use one bit. For example, here what are the variables? Notice in this program what are the variables? The variables are a, b, c, x. You can notice these are the variables in this program. Okay, and the question is saying that at every point you find which variables are alive, which variables are dead, and what you do, for every variable you use one bit. Okay, let me tell you that if a variable is dead you represent by 0, and if a variable is alive then you represent by 1. Okay, very simple. Now let's see, just use the definition. We have already seen the definition of live variable at a program point P. So just use that definition and let's find. First, let's find for this first program point. Okay, let's assume you are standing here. Then tell me, means you are standing just before this instruction. Immediately before this instruction, you are standing. So tell me which variables are alive, which variables are dead. You can see these are the variables A, B, C, X. These are the variables. So tell me, when I'm standing here at this point, when I'm standing, then you can see that variable X I'm using, I'm going to use. So I can say that at this program point, starting from this program point, you can notice we are going to use X. So I can say at this program point, this X is alive. Okay. What about A? Starting from this program point, you can notice that we are assigning A here. So there is only one path because there is no jump instruction, there is no go to instruction. All these instructions, they will execute in this simple order from top to down, this straight order, they will execute. And you can see that when I'm standing here, then before using A, starting from this point, remember, starting from this point, you can notice that before using A, here we are using A, but before that, we are already assigning A. So I can say that there is no path, starting from this point, there is no path where we are using A before defining it. Yes or no? There is no such path. So I can say that at this point, A is dead. I can say 0. A is dead. Okay, what about B? Starting from this point, are we going to use B before assigning it? No, you can see here we will use B, but before that we are assigning it. So I can say at this point, this B is also dead. Starting from this point, starting from this program point, are we going to use C before assigning it? No, here we will use C, but before that we are already assigning C. So I can say at this program point, C is also dead. I hope you understood. Okay, very simple, right? So remember, at this program point, the information, the liveness information we have represented using a bit vector 0001. The question is saying the order is ABCX. Okay, what about the next point? Let's focus on this point now. Tell me, starting from this program point, are we going to use A before assigning it? Yes, we are going to use A before assigning it. So I can say A is alive. Starting from this point, are we going to use B before assigning it? No, here we will use B, but before that we are assigning it. Okay, remember we are standing here. Just before the second instruction we are standing. So you can see that B is dead. At this point, B is dead. And starting from this point, are we going to use C before assigning it? No, here we will use C, but before that we are assigning it. So I can say at this point, C is also dead. What about X? Are we going to use X starting from this point? Are we going to use X before assigning it? Yes, we are going to use X before assigning it. So X is actually alive. Okay, very simple. What about the next? Now we are standing here at this program point. So tell me which variables are alive, which variables are dead. You can see starting from this point. Now we are standing here. We will start from this program point. Starting from this program point, you can see we are going to use B, we are going to use X. Okay, so B is alive, X is alive. You can see that C is dead because before using C, we are actually assigning C. So C is actually dead. Okay, and what about A? Tell me, what about A? For A, actually, we cannot say anything because maybe in the remaining program, maybe somewhere A is used. Okay, yes or no? So here you cannot say anything. Did you understand? When I'm standing here, now, maybe in the remaining program somewhere, maybe in some other basic block, maybe variable A is used. Okay, yes or no? Okay, here I can say that. Basically, let me tell you that at the end of this program, at this program point, see, at this program point, the information should be given. If nothing is given, then we can assume this is phi and we can say that A is dead. But maybe they can give you that at this program point already, maybe A is alive. Okay. So that will be given in the question. Don't worry. So do not worry about it. Okay. Or you can assume that here nothing is alive. Okay. You can assume this is the given information. Okay. For the last program point, this information is given that nothing is alive. Okay. So let's assume you can see that at the end, at the end, you can see no variable is alive. Assume it is given. Assume in the question it is given. Okay. You can assume that in the question it is given. So now you can say that yes, A is also dead. Okay, now you can say A is also dead because starting from this point, there is no path where we are going to use A. Okay, so that is the reason I can say A is also dead. Okay, what about this last program point? Now we are standing at this program point. So tell me, at this program point, you can notice that we are going to use C. So C is alive. The remaining are dead. Okay, that's it. So this is the answer. You can cross check this answer here. Okay, so you can see the answer that we got. Okay, for the first program point, you can see only X is alive, the remaining are dead. You can see X is alive, the remaining are dead. Okay, for the next program point, A comma X are alive, the remaining dead. AX are alive. For the next program point, BX are alive. You can see BX are alive. And you can see for this fourth program point, C is alive. So you can see C is live. Okay, I hope you understood this point. So we have seen the definition of live variable. I hope you understood how to find at some program point P, standing at some program point P, how to find whether some variable is alive or dead at that program point P. All you have to see that, okay, standing from here, you just take a binocular, okay, and you just check, is there a path where this variable V will be used before reassigning. Okay, before assigning variable V, are we going to use variable V on some path? Okay, if it happens, if there is at least one path where we are going to use this variable V before assigning it, then you can say that at this program point P, I can say that V is alive. Otherwise, V is dead. Consider this question. This control flow graph is given to you. This CFG is given to us. Why is Z live at exit of N5? Why is Z not live at the entry of N5? Why is X live at the exit of N3? This is a very simple question. Just apply the definition that we have seen. We have already seen the definition of live variable. A variable is live at a program point in the program if later in the program its value will be will be used, its value will be read before it is written again. Okay, so you can read this. A variable is live at a program point P if there is a path from P that contains a statement that will use V, and there is no definition of V on this path from P to S. Okay, before using V, there is no definition of V. So this type of at least one path should be there starting from the program point P. In this case, we will say that variable V is alive at the program point P. Otherwise, it is dead. A variable that is not alive, that is dead. Very simple. So let's solve this question. This is an interesting question because here you have a control flow graph with loop. Okay, there are loops here. So let's solve the first question first. That is why this variable z is live at the exit of n5. This n5 is the basic block, and the question is asking at the exit here. At the exit here we need to check. Remember, this is the exit of n5. This is the exit of basic block n5. Okay, now remember you are standing here. I told you where you need to check, you just stand there. Okay, so remember, now I am standing at this point. At the exit of n5 I am standing. So you tell me, starting from this starting from this point, is there any path where z will be used before assigning it? Just tell me simple point. You can notice, if I take this path, notice if I take this path, then we are assigning z, we are not using z, we are assigning z. Okay, so definitely this path I cannot take. Yes or no? Because on this path I am assigning z, I am not using z. So this path will not work for me. I need to find at least one path where z will be used before assigning. Okay, so definitely I can say that this path will not work for me. What other path is possible? Starting from this point, there is only this other path is possible. Let me go on this path, because you can see, starting from the exit of n5, I am standing at the exit of n5. Either this path is possible, but this path does not work for me, because in on this path we are not using z before assigning it. We are actually assigning z, we are not using z. Okay, so let's check the other path. You can see this other path. Let me check. Let me check this other path. Let me go. Okay, let me check. Is it possible that z will be used? Okay, is it possible that z will be used? Let's see. Now you can see here. Yes, z will be used before assigning. Okay, did you notice that on this path, okay, starting from exit of n5, starting from this program point, there is at least one path where z is used before assigning it. So yes, definitely you can see that z is alive at exit of n5. Means, okay, at this point I can say z is alive. Z is not dead at this point. Did you understand? This is a beautiful question. I hope you understood. Let's see the next one. Let's see this one. Why is Z not alive at the entry of N5? Now we need to check at the entry of N5. This is the basic block. At the entry, this is the entry of N5. Now you need to stand here. Okay, now you need to stand here. So this is the entry of N5. Okay, so just stand here and you tell me, when I'm standing here, is there any path starting from this point? Is there any path where z will be used before assigning it? No, because when you start at this point, you can notice immediately z is assigned. And you can notice, when I start from this point, starting from this point, the first instruction on every path, whatever path I take, the first instruction that I will execute, that will be z equal to 1. Okay, yes or no? So you can notice, starting from this point, immediately z is assigned. So whatever path I take, okay, all the path if I consider, then you can notice that before using z, we are already assigning z. So definitely at this point I can say that z is dead. At this point, I hope you understood. Let's see the next one. Why is x alive at the exit of n3? Now we are talking about the exit of n3. This is the exit of n3. Now you are standing here. Okay, so just stand here at the exit of n3. You stand. Now you tell me, starting from here, starting from this point, just tell me, are we going to use x? We are checking x, remember? Are we going to use x on some path before defining it, before assigning it? So you can see that if I go on this path, then before using x, I am actually assigning x. So this path will not work for me. Okay, but let me go on this path. Okay, let me use this path. Let me check on this path. Maybe I will use x before assigning it. Okay, so let me go like this. So I'm going on this path. Yes, you can notice if I take like this, you can see starting from this point, if I take this path, then you can see here also we are not defining x. Then if I take here, you can notice here we are using x before defining it. So that's it. Yes. So I can say that at this point, x is alive. I hope you understood this point. Okay. So the definition of live variable at some program point is that clear. We have taken a lot of examples to understand this concept. This is the important concept. Let's solve this question. A control flow graph is given to us, which has some loops also. Show execution path. Show some execution path along which a this variable a is live at the exit of node 5. So we need to check at the exit of node 5. You can see this is the exit of node 5. Okay, so you are standing here because this is the exit of node 5. Okay, so just tell me at this point the variable a is that alive or dead. Let's see. So you can see, is there some path starting from this point? Is there any path where variable a will be used before assigning it? You can see when I start from here, there is only one path I can go initially. Okay, you can see initially there is only one path that I can go. You can see initially there is only one path that I can go. Like this, I can go. Okay, and then you can see, then I will go like this. Okay, then here you can see we are not defining a, we are not using also, we are not defining also. But if I from here, if I take this, if I take this, now here we are using a. Yes or no? Here we are using a. So you can notice, yes, starting from this point, from this program point, if I start, then there is some path. There is at least one path where we are using a before defining it. Okay. So that's it. I can say that at this point, remember, at the exit of node 5, I can say a is variable a is alive. Okay, very simple. And the question is asking, show some execution path. At least one execution path we need to show. So yes, we have already shown it. Okay, in this diagram I have shown it. Okay, you can see in the diagram I have already put the arrows. So you can see. I hope you understood. Let's solve this question. Show an execution path along which this variable a is alive at the exit of node 3. Now we are discussing node 3. At the exit of node 3. So you can see this is the exit of node 3. Okay. So let's see. Starting from here. Is there any path on which variable a will be used before assigning it? So you can see that if I go on this path, then variable a will be assigned before used. So this path will not work for me. Yes or no? This will not work for me. So let me take this path. Let me check on this path. Okay, on this path, you can notice here we are assigning a, also we are using a. So tell me, assignment first happens or use first happens? In this instruction we are using a, also we are assigning a. First what we are doing, are we first using a or are we first assigning a? First we are using a, yes or no? First we will use a, we will calculate a plus I, then we will assign a. So here I can say that here basically we are using a. Okay, yes or no? Here overall I can say that we are using a. So that's it. Okay, so I can say that at the exit of node 3, this variable a is alive. I hope you understood. Very simple. Let's solve this question. This is another beautiful question. This control flow graph is given to us, and the question is asking, is variable a alive at the exit of node 5, at the exit of node 3, at the exit of node 4, also at the entry of node 5, entry of node 3, entry of node 4? Okay, so let's see all of them. So tell me yes or no for all these 6 questions. We need to check for the variable a. You can see variable a at the exit of node 5. Okay, this is the exit of node 5. So tell me at this point, this variable a, is it alive or dead? Means now you are standing here. So starting from this point, from this program point, is there any path where variable a will be used before defining it? Yes, you can see that. Okay, you can go like this and you can see here variable a will be used before defining it. So I can say at this point, at the exit of node 5, variable a is alive. Yes, very simple. Okay, what about the next? Pause the video, solve this question. Yes, no, yes, no, you just tell me and write your answer in the comments. Then you play this video and you see the explanation whether your answer is correct or not. Okay, so let's see. What about the exit of node 3? So this is the exit of node 3. Now, starting from here, is there any path where variable a will be used before defining it? Yes, you can see this path. You can consider this path. Here variable a is used before defining it. Okay, so here also I can say that at this program point variable a is alive. What about the next? At the exit of node 4, this is the node 4. Now this is the exit of node 4. Now we are standing here. Okay, tell me, starting from here, is there any path where a will be used before defining it? Yes, you can just take this path. Here a will be used before defining it. Okay, so very simple, I can say this is also yes. Okay, what about the next? Entry of node 5, node 3, node 4. Let's see about them. So now you can see that. Let's check the entry. Already the first 3 questions we have done, the answer is yes, yes, yes. Okay, let's see the next 3. Entry of node 5. Now you are standing here. This is the entry of node 5. Okay, now you are standing here. Tell me, when I'm standing here, then starting from here, is there any path where variable a will be used before defining it? Yes, here variable a will be used. Here we are using variable a before defining it. So definitely I can say that at the entry of node 5, variable a is alive. Yes. Okay, what about the next? At the entry of node 3, this is the node 3. At the entry of node 3, now you are standing here. Okay, so tell me, starting from here, is there any path where a will be used before defining it? Yes, again you can notice, you can take this path. Okay, starting from here, you can just take this path, and here you can see on this instruction a is used before defining it. So I can say that yes. What about the last? At the entry of node 4, now you are standing here at the entry of node 4. Tell me, Starting from here, is there any path where a will be used before defining it? No. You can see immediately we are defining a. So whatever path I consider, if I consider all the path starting from here, if I consider all the paths, then you can notice that variable a will never be used before defining it. Immediately we are defining variable a. So I can say that here no. I can say that at this point, this variable a is dead. Understood? Very simple. So we have seen the definition of live variable at a program point P, and we have done a lot of practice. I hope you understood this definition, the concept, and all the questions that we have done so far. Okay, so you can just read the definition here. We call a variable x live at point P if there is some path starting from P along which the value of x will be used before redefinition. If it does not happen, then x will be dead. Not alive means dead. Okay, so you can see a variable v is live at a point P if there is some path from P to some use of v, and that path does not contain a redefinition of v. Okay, so this definition we have seen, and we have done a lot of practice to understand this definition. Now let's start live variable analysis, or I can say liveness analysis. In short, we will call it LVA, live variable analysis. So what is this live variable analysis? Live variable analysis determines for all program points the set of variables that are alive. That's it. So basically, in this live variable analysis, in this LVA, what we do, for every program point in the control flow graph, for every program point, we find out what is the set of live variables. Okay, for every program point we need to find the set of live variables at that program point. Very simple. So you can see the liveness analysis, compute the live variables between each statement. Yes, because you already know that between two statements there is a program point. Okay, for every statement there is a program point before it, there is a program point after it. For every basic block there is a program point before it, there is a program point after it. So you can see liveness analysis means we need to determine the set of variables that are alive at all program points. Okay, and remember, this liveness analysis, this is example of data flow analysis, because here we are checking the flow of data, how the data is flowing. For example, is some assignment to a variable going to be used somewhere or not? Okay, so we are checking the flow of data, yes or no? We are checking the flow of variable. If I am assigning to some variable, then I want to find whether this assignment is dead assignment or not. Okay, means this assignment will ever be used somewhere or not. Okay, so basically this is the data flow analysis. Okay, you can read this. Liveness analysis tells us at any program point, at any particular program point, whether the current value of variable will ever be used or not. A variable that is not alive, that is dead. A dead value you don't need to keep in your program, and all the dead assignments you can remove from your program. Okay, very simple. So the definition of live variable at a program point that we have already seen, and remember the analysis corresponding to dead code elimination. Before we perform the dead code elimination, the analysis that we need to do, that is basically analysis. And in this liveness analysis, we determine for all the program points what are the set of live variables at every program point. Consider this example, and in this example you tell me at every program point what is the set of live variables. Okay, so what are the program points in this example? Tell me. First, you notice here that there is a program point here. Okay, there is a program point here, 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 and this last, it will be given. I told you. Okay, it will be given. Let's assume it is given that nothing is alive. Okay, now you tell me on every program point what is the set of live variables. First of all, you notice what are the variables in this program. We are doing the live variable analysis of this program, means on every program point, we are going to find the set of live variables. Okay, what are the variables here? You can see variable is x, y, z. Only three variables we have. Okay, so let me use bit vector. Okay, let me use bit vector. So if a variable is dead, I will use 0, and if a variable is live, I will use 1. Okay, and let me use this order. Let me use this order x, y, z. This order let me use. Okay, so just tell me, when I'm standing here, okay, at this program point, you tell me x, y, z, which of them is alive, which of them is dead. Okay, so you can see that starting from here, just focus here. When I start from this point, is there some path where variable x will be used before defining it again? Starting from here, you can see immediately I'm assigning x, so I can say that x is dead. Okay, because when I start from here, from this program point, then immediately this x is assigned. So before we use x, already x is assigned. So x is dead at this point. X is dead. Okay. What about y? Yes, y is actually used. Okay, so y is alive at this point. What about z? Yes, z is also used. You can see. Okay, you can notice z is also used before it is assigned. Z is also used. So z is also alive. Very simple. What about the next program point? Now we are standing at this program point. Tell me, at this program point, starting from here, now we are going to start from here. Starting from here, variable y, is that used before defined? No. Immediately we are defining y. Before using y, here we are using y, but before that already we are defining y. So you can see that y is dead. Okay, what about z? Yes, z is used. Okay, z is alive. At this point, z is alive. What about x? Starting from here, you can see, are we going to use x? When you start from here, are you going to use x before you define it? No. You can see here you will use x, but before that you are defining it. Okay, so I can say that x is also dead. What about the next? Now you are standing here. At this program point, we need to find. You can see that y comma z are used, so they are alive. And you can see immediately x is assigned. We are defining x, so I can say that x is dead. What about this? Now I am standing at this point. Okay, you can see here x is used. Yes. Okay, so you can notice x is actually alive, and you can see immediately z is assigned. Before we use z, actually immediately z is assigned, so I can say z is actually dead. Okay, and y, you can see that at the end this is already given. Please notice, at the end it is already given that nothing is alive at the end. Okay, this is given in the question. You can see, let me tell you that here at the end, at this program point, it is given in the question that at the end nothing alive. Okay, very simple. And we need to find on these program points. On these program points, we need to find. Okay, so you can see that when I'm standing here, then this z is immediately assigned, so that is dead. X is used, so x is alive. And you can see y, that is not used, so y is also dead. Okay, and finally, now you are standing here. Here you can see x is used, so x is alive. Z is assigned, so Z is also dead and Y is also dead. Okay, so that's it. I hope you understood this point. Clear? So you can see we have used the bit vector and we have solved this question. The bit vectors we have used. To indicate that a variable is dead, we are using 0, and to indicate that a variable is alive, we use 1. And finally, this is the liveness information at every program point. This is called live variable analysis. Let's see the next point in the live variable analysis. That is, for each instruction n, we define the following set. One is in live of n, and another is out live of n. Because I told you that for every instruction there are two program point. Correct? When you have a instruction n, let's assume statement n, or I can say instruction n. This is the instruction n. For this instruction n, there are two program points. What are those? You can see there is a program point immediately before it. There is another program point immediately after it. Okay. So let me tell you the set of variables which are alive here, that will be indicated by in of, either you can say in of n, or you can say in live of n. Okay. Or you can say live in of n. You understood the point that for every instruction, for every statement, there are two program points. One is immediately before this instruction, another is immediately after this instruction. So remember the set of variables alive here, that will be indicated by in of n, and the set of variables alive here, that will be indicated by out of n. You can say out of n, or you can say out live of n. Means at the end of this instruction n, what variables are live. Okay, very simple. So you can see either you can say out of n, or you can say out live of n, or some people also write it live out of n. Basically you understood the point that for every instruction there are two program point, and the set of variables alive on these program points, these are indicated by these two functions, these two set, basically not function. So these two set we define. So remember, we already know that for every instruction, for every statement, there are two program points, and the set of variables alive on these program points, that is indicated by these two set. You can see there is in of n, there is out of n, set of variables before this statement n, and set of variables after this statement n. Okay, very simple. So remember here, you can see we consider in live of n, out live of n, the set of variables which are live immediately before n, and the set of variables which are live immediately after n. Okay, so you can see in of I, that means the set of variables that are live at the entry of instruction I. Out of I, that is the set of variables that are live at the end of instruction I. Very simple. Also, let me tell you, we already know in the previous lecture also I told you that the live variable analysis, this is a backwards analysis. Okay, don't worry if you did not watch the previous lecture. Let me tell you that some analysis are forward analysis, some analysis are backward analysis. This live variable analysis, this is backward analysis, and we will also study available expression analysis, also constant propagation analysis. Those are forward analysis. Okay, so let me tell you the difference between forward analysis and backward analysis. Okay, so let me tell you that there are two type of analysis. You can see there is a forward analysis, and there is something called backward analysis. Backwards means the reverse direction. Okay, backwards analysis. So the point is very simple. In the forward analysis, you go in the forward direction. Means in the forward analysis, let's assume this is your instruction n, and in the backward analysis also, let's assume this is the instruction n. Now remember, in the forward analysis, you can see this is the in of n, and this is the out of n. Okay, and remember, in the forward analysis we go in the forward direction, so we have the information about in of n, and we calculate the information about out of n. So remember, in the forward analysis, this out of n, this we write as a function of in of n. Means basically we calculate out of n from in of n. Okay, is this clear? Based on this instruction n. So I hope you understood this point, that in the forward analysis, this out we calculate from the in. Okay, to calculate out we use in, also we use this given instruction. In the backward analysis, what we do, we go in the backward direction. Okay, we go in the backward direction. So you can see, remember one thing, that before this instruction, the set of variables that are alive, that is indicated by in of n, and after this instruction, the set of variables that are alive, that is indicated by out of n. But in the backward analysis, we go in the backward direction. It means we already have out of n and we calculate in of n. And remember, to calculate in of n, we use out of n. So we calculate this in of n in terms of out of n, or I can say from out of n, we calculate in of n based on this instruction n. Did you understand the forward analysis and backward analysis? And let me tell you that this live variable analysis, LVA, this is a backwards data flow analysis. It means the direction of this analysis, that is reverse or opposite, or I can say backwards. Means if you have this instruction n, then for this instruction n, you already know that there are two program points. This is the program point, this is the program point. So the set of variables alive before this instruction n, immediately before this instruction n, that is indicated by in live of n, and the set of variables alive immediately after this instruction n, that is indicated by out live of n. But because this live variable analysis, this is backward analysis, it means that this in live we will calculate from out live. Okay, is this clear? This is basically the reverse. You can see, to calculate the in live of n, we are going to use out live of n. Okay, and also it will depend on this statement. What is this statement? What variables are assigned here, what variables are used here, so it will depend on that. So I can say it will also depend on this statement n. Okay, so I hope you understood this point. This is called backward analysis. Okay, in the backward analysis, this incoming information we calculate from the outgoing information. Okay, very simple. I hope you understood. And let me tell you, this function we will call it transfer function. That's it. So to calculate this in of n, we use out of n. We write this in of n as a function of out of n, also this statement n. It will depend. Basically, to calculate this information, we need this information, means what is this statement, and also what is out live of n. I hope you understood this point. So you can read whatever I told you, that is written here, that we start the live variable analysis from the exit, because this is a backward analysis, yes or no. So we start from the exit, we don't start from the entry. In the forward analysis, you will start from the entry node. Okay, but in the backward analysis, we will start from the exit node. Okay, so you can see, we start the live variable analysis from the end, or I can say from the exit node, not from the beginning. Next, you can see, we calculate in live from out live. Okay, this in live we calculate from this out live. Next, you can see, this in live of n, it will depend on out live of n, also on the statement n. Next, you can see, we write this in live of n as a function of statement n and also out live of n. And this function is called transfer function. Okay, I will show you what is this function. Okay, but this function is called transfer function. We will find this transfer function, we will prove it. But I hope you understood this point. What is backward analysis? How do we do the backward analysis? And in the backward analysis, this in information we calculate from the out information. Okay, I hope you understood. You can consider this example here. You can see here, this information we calculate from these two. Okay, is this clear? Okay, so it's like this. You can assume that these two will be given to you. You can assume that these two will be given to you, and this is what you will find out. Okay, so this is called backward analysis. I hope you understood this point. You can see here in this diagram that we have this basic block B, and I told you for the basic block B, there are two program points. One is at the entry of basic block, another is at the exit of basic block. Okay, so you can see, for the basic block also we define two set, means the set of variables alive at the entry of this basic block, also the set of variables alive at the exit of this basic block. And remember, because this live variable analysis, this is a backward analysis, so this in of B we calculate from out of B also based on this B. So you can easily see that this in of b, this we write as a function. Okay, and this function, remember, this will depend on b also, on this basic block also it will depend, also it will depend on out of b. I hope you understood this backward analysis. What is the meaning of backward analysis? I hope you understood that point. Okay, now let me tell you one more important point, that is, when we say live at an instruction, what it means. I told you that for every instruction there are two program point, one immediately before it, another immediately after it. But sometimes some people, some authors, they use the word live at an instruction. What this word means, because on the instruction there is no program point, that you already know, yes or no. I told you that for every instruction there are two program point, immediately before it, immediately after it, these are the program points. On the instruction there is no program point. So some authors, they use the word live at instruction. See, if I say live before instruction, that is very easy to understand. Live after instruction, that is easy to understand. But some people, they use the word live at this instruction. So what it actually means, let me tell you. So remember, whenever some author uses this word live at instruction, live at an instruction, it means live immediately before that instruction. Okay, this is an important point. Some authors, they use this word live at instruction. So it means immediately before the instruction, not immediately after the instruction. It actually means live immediately before the instruction. So for example, you can see in this example here, this is the statement n, and the set of variables alive immediately at the immediately after this instruction, that is out of n, and the set of variables alive immediately before this instruction, that is in of n. Now some authors, they use the word live at instruction n. Okay, some authors, they use the word live at instruction n. There is no in or out. Okay, they simply use the word live at instruction n. Live at instruction n. So what it actually means, remember, this is actually same as in. This is same as in live of n. So please understand, don't confuse. Okay, whatever the author want to use, let them use, but you don't confuse. You remember that if the author is saying live at instruction n, it actually means immediately before this instruction n. Okay, please understand. So remember, live of n, that is exactly same as in live of n, because there is no program point on the instruction. There are only two program point, one is immediately before the instruction, one is immediately after the instruction. So when I say live at instruction n, it means live just immediately before the instruction n. So live of n, that is same as in live of n. I hope you understood all these points. Now let me tell you, we need to study total four concepts in the live variable analysis. We need to study live analysis, liveness analysis for individual statement. First, we will consider individual statements. Then we will consider basic blocks. Then we will consider control flow graph. In the control flow graph also, we will first consider without loops. Then we will consider with loops. Okay, let me tell you all the concepts that we will study in this lecture. These we will study also. So far also we have studied with proper logic, intuition and proof, and a lot of practice we will do for every concept that we study. Okay, so you can see all the concept, all the formula we are going to discuss. Every formula we will discuss with proof, and a lot of practice and all the gate PYQs we are going to solve. Okay, so let's start. In the live variable analysis, first we will discuss the liveness analysis for individual statements. So our topic is liveness analysis for individual statements. We are going to consider individual statements, and then we will see how the liveness analysis will be calculated. To discuss live variable analysis for individual statements, just tell me the answer for these two questions. What makes a variable live and what makes a variable dead? Think about it. So far, we have already seen the definition of live variable at some program point, and when a variable will be dead at a program point. A lot of examples we have done. So tell me, what makes a variable live and what makes a variable dead? Very simple answer. What makes a variable live? The use of that variable. Yes or no? Use of that variable will make it live, and assignment will make it dead. Yes or no? Assignment will make it dead. Assignment means definition. Okay, so you can see that definition will make it dead and the use will make it alive. Very simple. So you can see what makes a variable alive, that is use. An instruction makes a variable alive when it uses it. And an instruction makes a variable dead when it defines it. Definition, or I can say that is assignment. Very simple. Let's consider this statement. In this statement, we are using y comma z and we are defining x. And very simple question I'm going to ask you. Let's assume this statement and we already have, okay, this is x equal to y plus z. And let's assume that the out of n is already given to you. Okay, because I told you that the liveness analysis, that is a backward analysis. Okay, we do the liveness analysis in the backward direction. Okay, so I told you that to calculate in of n, what is in of n? In of n basically means immediately before this instruction, the set of variables alive immediately before this instruction, that is in of n, and the set of variables alive immediately after this instruction, that is out of n. Let's assume that out of n is already given to us, that is x comma w. Okay, x comma w, this is already given to us. So please understand, this out of n is given. Okay, and this statement is given. Now we need to calculate what will be in of n. Can you tell me what will be in of n? Just use the logic, pure logic. After some time we will see the formula also, but for now just use the logic only. Use the definition of live variable at some program point. You can notice that I am standing here. Yes or no? You can notice now this is our program point. I am standing here. Okay. So you can see we are standing here. So if I am standing here, just tell me, just use the logic and tell me, starting from here, starting from this boundary, which variable will be used? You can see y comma z will be used, and you can see that this x is assigned immediately. We are assigning to x, so x will be dead. Yes or no? So you can easily see that what will be in of n. What will be in of n? That will be basically, you can notice, starting from here, immediately you can see y comma z are used. Okay, and you can also see that starting from here, we will never use x before defining it because we are immediately using x. Okay, sorry, because we are immediately assigning to x. Okay, so before using, starting from here, before using x, we are immediately assigning to x, so I can say x is dead. So definitely here in of n will not contain x. Okay, one thing you notice, out of n already contains x. This is given to you. Why? What is the reason that here x might be alive? Tell me, what is the reason that x might be alive here? What might be the reason? Maybe in the future program, maybe in the remaining program x is used. Yes or no? Okay, maybe for example, maybe here, somewhere here x is used. Okay, maybe here x comma w are used. Okay, that is the reason out of n is already given to you x comma w. Means if you start from here, then maybe x comma w is used somewhere. But the point is that when you start from here, then you can see before using x, we are assigning to x, so x is already dead. So you can see that what is in of n, that will be y comma z, and also w also. Why w? Because you can see that that is already, the question is already saying that if you start from here, you can see this w is also used somewhere. Like if I start from here, then somewhere w is used before it is defined. If I start from here, then somewhere w is used before it is defined. So tell me, if I start from here, then also you can notice that w is used before it is defined. Is this point clear? Very simple point I am telling you. The question says that out of n is x comma w, means starting from here, somewhere x comma w is used before they are defined. So just tell me, If I start from here also, then also you can notice that in this instruction there is no w. If I start from here, then you can see w will be used before it is defined. Okay, so that's it. So I can say w is also alive, but remember x will be dead. Okay, so this is your in of n. I hope you understood this point. Tell me, is this point clear? So pure logic we are using, we are just using the definition, nothing else so far. We will see the formula also, but so far we are only using the definition, nothing else. So notice one thing, that this instruction, what it has done, please notice, this was our instruction n x equal to y plus z. Okay, now just make some observation that in this instruction, what we are using, in this instruction n, what we are using y comma z. And in this instruction n, what we are defining, we are defining x. Okay, and one more thing you can notice, that the question was saying that out of n that has x comma w. So remember, here, from here, or I can say at this point, actually x comma w are actually alive. But you can see when I go in the reverse direction, the LVA, live variable analysis, that is backward direction analysis. So you can see when I go here, then this x has died. So you can see at this point x is alive. And when I cross this instruction in the reverse direction, when I cross this instruction, now x is dead. So who killed it? Tell me, who killed it? This instruction killed it. Do you agree with me? So you can notice, I hope you understood this point. Just understand logically that at this point, x comma w are alive. And in the reverse direction, when I cross this instruction, then x has died. So who killed x? This instruction killed x. Why? Because this instruction has assigned to x. And I told you, who will make a variable alive? Use will make a variable alive, and assignment will make a variable dead. Okay, so you can see this is what I've written, that this statement has killed x. Okay, in the reverse direction, when you cross this statement, then this statement will kill x because this is assigning to x. So this statement will kill x. I hope you understood. And remember, this will generate y comma z, because in this instruction y comma z are used. Okay, so that is the reason, when you cross this instruction, then remember y comma z will become alive. So this instruction will make y comma z alive, and this instruction will kill x. This is what I've written here. I hope you understood. Now let's consider the next statement. Next statement is x equal to 3. And you can see the out of n is given to you. We need to calculate in of n. Very simple question. Now the statement n is x equal to 3. Okay. And already the question is saying that out of n that is given to us, that is xyz. This is the out of n. And we need to calculate what is in of n. This is what we need to calculate. I told you that live variable analysis, this is a backward analysis. We will go in the backward direction. Okay. Now, just tell me a simple point. Look at this instruction. In this instruction, what we are using? We are not using any variable, but we are defining x. Okay. And remember, out of n, that is xyz, means at this point, xyz are alive. Okay. This is what it means. Yes or no? You can see here x, y, z are alive. Okay, this is given. This is given. Now, what it actually means? Why they are alive? Maybe in future they are used. Okay, maybe somewhere they are used. Okay, used x, y, z. Yes or no? Somewhere we are using x, y, z. So maybe that is the reason they are alive. Here at the end of this instruction, they are alive. Okay, you tell me. If I stand here, I am standing here. So let me know, if I start from here, starting from here, this variable x, it will be dead or alive? you can immediately see that when I start from here, then before using x, immediately you can see x we are assigning. So x is definitely dead, yes or no? So you can notice x is already dead at this point. Just use the definition. If I start from here, immediately x is assigned. So definitely, if I start from here, then on every path, before using x, we have already assigned to x. So I can say x has died. Okay, now x is dead. Now what is alive then? You can see y comma z. Yes, y comma z, they are alive. What is the reason? Because if I start from here, this instruction does not have y comma z, but you can see that somewhere y comma z are used before they are defined. So definitely I can say that y comma z, that will be alive here. Okay, so in of n, that is equal to y comma z. I hope you understood this point. Okay, clear? So you can read this here, that what this statement has done. Here we are assigning to x. So remember, this statement has killed x, and it has generated nothing because we are not using any variable here. Okay, remember, the use of variable will generate, and the assignment of variable, that will kill. Okay, so you can see, just let me write it here to understand this point, that our statement was x assigning 3. Okay, you can see in this statement, you can notice what we are defining. We are defining x. Okay, and you can see what we are using in this statement. We are using nothing. Okay, now you can see the question is saying that at this point, at the end of this instruction, at this point you can see that x, y, z, these were actually alive. Okay, you can see, but now notice that here only y comma z are alive. Okay, so remember, and we are going in the reverse direction. We are going in the reverse direction, and notice that at this point x, y, z are alive, and when you cross this instruction, then x has died. So who killed x? This statement killed x, because this statement is assigning to x. So this statement has killed x, and because this statement is not using any variable, so this statement has not generated anything. This statement has not made any variable alive. Okay, this y comma z were already alive here, so they are also alive here, because this statement did not kill them. Okay, yes or no? You can see at this point y comma z are already alive, and when you cross this instruction in the reverse direction, then y comma z are still alive, because this instruction did not kill, but this instruction has already killed x. Okay, very simple, understood? Now tell me the answer for this question. What will be in of n? The same statement we have, out of n, that is y. What will be in of n? So in of n, what that will be, you can see when you cross this instruction in the reverse direction, this instruction will kill x. Okay, already there is no x here. Okay, so don't worry. If there is x in the out of n, if there is x, then this statement will kill x. But because already there is no x here, so you don't have to worry. Okay, and you can just simply say that in of n, that also will be y. But please understand, this statement will actually kill x, that you already know. This is x killer. Okay, this actually kills x. But because already in the out of n you don't have x, so you don't see the impact. Okay, yes or no? The impact is not visible, but remember, this instruction will kill x because this is assigning to x. So this is the x killer. I can say this statement is x killer because this is assigning to x. So you can read this here, that this statement, this has killed x, but because out of n does not have x, so we could not see the impact. Okay, but remember, because this instruction is assigning to x, so this will actually kill x, and this has not generated anything. This has not made any new variable live. Okay, let's see this question. Now our statement is print x comma y. Here we are not defining any variable, we are not assigning any variable, but we are using variable x comma y. Okay, so now you can see that our statement n, that is print x comma y, we are using x comma y. Okay, and let's assume the question is saying that let's assume y comma z, these are alive immediately after this instruction. Okay, so you can see that out of n means here you can see out of n, that is y comma z. Okay, and we need to find what will be in of n. This is what we need to find. So remember, we are standing here, and you remember that liveness analysis we do in the reverse direction. Okay, so let's see. You can notice in this statement we are using x comma y, we are not defining any variable. Okay, and remember, at the outside, you can see at the immediately after this instruction n, this y comma z are alive. Why they are alive? Because maybe when you start from here, maybe somewhere y comma z are used. Yes or no? Maybe somewhere y comma z are used before they are defined. So this is the simple logic. Now you tell me what will be in of n. Just use your definition. You can see if I start from here, you can see immediately I am going to use x comma y. So yes, x comma y will be alive. Okay. Also you can notice that this instruction will not kill anyone. So this z is also alive, because you can see if I start from here, let me start from here, then you can see immediately I am using x comma y, so x comma y are alive. And you can see that now I'm here, and somewhere this y comma z are used before they are defined. So definitely I can say that if I start from here, then also I can find use of z before it is defined. So z is also alive. Or I can say that when you go in the reverse direction, this statement will not kill any variable. It will generate x comma y because it is using x comma y. So remember, it will generate x comma y, but it will not kill anyone. Okay, so you can see this is in of n. I hope you understood. So you can read this, that this statement has killed nothing because there is no assignment here, and it has made x comma y alive. Okay, so very simple point. It has not killed anyone. Okay, so just let me quickly write it here. So you can see our instruction was print x comma y, and we already know that here what variables we are using. We are using the variables x comma y. Okay, and remember, use of a variable will make a variable alive. And what we are defining here, we are not defining any variable. Remember, definition of a variable will make that variable dead. Okay, yes or no? So very simple. Now you can see this is what we are doing, and here this out of n, that was given as y comma z, and this in of n, we have calculated that this is x y z. So you can see that what this has done, what this instruction has done, this instruction has not killed anyone. This has not killed anyone because there is no assignment in this instruction. So this has not killed anyone. But remember, this has made x comma y alive. Okay, it has generated x comma y. Very simple. I hope you understood this point. Now let's see this statement. This is a very interesting statement because here we are using x comma y, and here we are writing x. So remember, we are using x comma y and we are defining x. Okay, so now let's see what will be the impact of this statement on the liveness information, or I can say on the liveness analysis. So let's assume the question is saying that, let's assume the out of n, this is the statement n, and out of n is x comma z, means immediately after this statement n, these are the variables that are alive. We need to find what is in of n. Immediately before this statement, the set of variables that are alive, that we need to find. Okay, so let me write here. You can see this is the statement n, instruction n. In this instruction, you can see that we are assigning to x plus y. So we are using x plus y, x comma y we are using, and we are assigning also x. Okay, now the question is already saying that out of n means here the set of variables that are alive, that is x comma z. Okay, so you can see x comma z are alive here. Why they are alive here? Tell me why they are alive here. Because see, at this point you are standing here x comma z are alive, it means somewhere they might be used. Starting from here somewhere x comma z are used before they are defined. Yes or no? Very simple. Now let's see, we need to find what will be in of n, what that will be. So where are we standing? We are standing here. Okay, here we are standing. Just use your logic, pure logic you use, and tell me, what do you think, which variables will be alive if I start from here? You can see if I start from here, one thing I can notice that y is used. Okay, so there is no confusion about y, because if I start from here, immediately I can say y is used. Okay, you can see here we don't have any z. We are not using z, we are not assigning to z. So I can say this instruction will not kill z. We are going in the reverse direction. Please understand. We are going in the reverse direction. So this instruction in the reverse direction, this instruction will not kill z. So z is also there because it is not killed. Now the interesting thing is, what about x? Because this instruction is assigning x, also it is using x. So tell me, first use is happening or first assignment is happening? From here, you can see we are standing here, starting from this point. Okay, think from here, starting from here, first we are using x or first we are assigning x? First we are using x, yes or no? Because you can notice, first we will do x plus y and then we will assign to x. So remember, first we are using x. Okay, is this clear? So remember, because starting from here, first we are using x before assigning it. So that is the reason I can say x is also alive. Okay, is this clear? Very simple point. So notice one thing, that this instruction was actually, this instruction has actually killed x, but it has also generated x. Okay, it has defined x means it has killed x, it has used x means it has generated x. So which is more powerful thing, I can say, this statement is killing x, also it is generating x. So what is the final conclusion? Will we say x generated or will we say x killed? We will say x is generated, because if you see from here, okay, if you stand here and if you see, then you will see that first we are using x before assigning it. So definitely at this point, at this program point, x is alive. I hope you understood this point. Okay, very simple. Let me tell you one more thing, one more logic. Let me tell you, in the forward direction I told you the logic, but the liveness analysis happens in the reverse direction. So in the reverse direction, what is happening, that also let me tell you. Okay, so you can see this analysis, see this we have done from from which point of view? From this position point of view, yes or no? So you can see from this point of view, from this point, from this point's perspective, we have seen the explanation. Okay, is this clear? Yes or no? Very simple. So from this point, from this point's perspective, we have seen the explanation. Okay, now let's see the explanation in the reverse direction. Remember, this instruction you can think as, here basically what is happening, first thing is that you will use x comma y, and let's assume you are storing in some t, and then you can see that you are storing this t in x, yes or no? So this is how you can think it. And now you can see in the reverse direction also you can go. So you can see that this instruction you can think like this, that first you are, okay, you are using x plus y and then x equal to t. Okay, yes or no? This is how you can think, basically I can say, think as. Now remember, now let's go in the reverse direction also. Already we know that out of n that was already given to us, that was x comma z. Okay, x comma z, that was out of n. Now we are going in the reverse direction because the liveness analysis happens in the reverse direction. So you are going in the reverse direction. In the reverse direction also you can notice one thing. In the reverse direction, you tell me, In the reverse direction, what is happening? First kill is happening or first generation is happening? In the reverse direction, you can see first we are killing. Okay, here you can see X killed. Agree? You can see. Just go in the reverse direction. In the reverse direction, you can see X is killed. Okay, but you can see, just keep going in the reverse direction. Just keep going in the reverse direction. First, X is killed. Okay, then you can see that X is used. Okay, X is generated. Agree? So I hope you understood the explanation. From both the perspective, I've told you that whether you think from this program point of view, or I can say from this program point of view. Okay, from this program point perspective, if you think, then also you can see that first we are using X, then we are assigning X. Okay, and you can see in the reverse direction also, if you think, then you can see in the reverse direction, first we are killing and then we are generating. So who has the final say? The final say is that X will be generated. Yes or no? This is the final say, that in of n, this is the final say that X will be generated. Okay, and you can see Z is already there, and also Y is also used here. Okay, you can see, because Y is also used. So X is generated, Y is generated, and this Z is not killed by this statement. Okay, so that is the reason X Z Y. This will be your answer. I hope you understood. So we have seen the reverse direction perspective. Okay, so you can see the reverse direction perspective also we have seen. So both the perspective we have seen. I hope you understood. So whatever I told you, that is written here, and this is a special instruction. Remember, because some students, they will make mistake here in this type of statement, because here we are using X comma Y and we are writing to X. Okay, so here you can notice that this instruction has generated Y. Okay, there is no confusion about Y, because this instruction has generated Y. This instruction kills X, also it generates X. Okay, so who has the final say? The final say is that we will consider X generated by N. It makes sense. Why? What is the reason? There are two reasons. Okay, you can understand either from the first reason point of view or from the second reason point of view. The first reason is that when you stand immediately before N, then you will see that that old value of X is used at N before it is overwritten. So I can say that X is alive immediately before N. So this is from the perspective of before the instruction. Yes or no? Immediately before the instruction, from that program point perspective, this is the understanding. Or you can understand in the reverse direction, you can understand that in the reverse direction also, you can notice in the reverse direction, first X is getting killed, then X is getting used. So in the reverse direction also, what is the final thing? That is X is used, or I can say X is generated. So this is the final conclusion. Remember that this instruction X equal to X plus Y, please understand this instruction will generate X. Okay, this is the final thing. I can say it will generate X and Y. It will generate X and Y. This is the final conclusion. Okay, is this clear? This instruction will generate X and Y. Or I can say that good has power over evil, something like this. Okay, so basically, if you are confused, who has more power? Should I consider X is killed or should I consider X is generated? Then remember, you can say that good has more power over evil. Okay, so I can say that basically Gen more powerful than evil. Okay, so like this. But the logic you understood, I hope you understood the logic that this statement, this is the final conclusion that this will generate X comma Y. Okay, and remember what this instruction will do? X equal to Y plus Z. What this instruction will do? This instruction will kill X and it will generate Y comma Z. Okay, and remember what this instruction will do? Print X. What this instruction will do? It will not kill anything. It will generate. It will generate X, not kill anything. Very simple. So notice one thing, that whatever situation you take, the variables which are used, these are generated. You can see in this statement we are using these variables, we are using x also, we are assigning x also, but the point is overall, because we are using xy, so they are generated. So notice one thing here also, the variables which are using, they are generated. Here also the variables which we are using, those are generated. So can I say that generated set of variables, that is same as the variables which are used? So remember, use is equal to generate. And also you can notice kill is equal to define. Okay, you can see here x will be killed, here x will be killed, but the point is first x will be killed in the reverse direction. I'm talking about in the reverse direction, first x will be killed, then x will be generated. So the final say will be that x is generated. Okay, so let me tell you, this is an important point, that from the live variable analysis point of view, in the context of live variable analysis, we use the word kill for assignment or definition, and we use the word gen means generate, for read or use. Okay, so please understand that this word kill, this is another synonym for definition, and this word generate, this is another synonym for use. So from now onwards, when I say use, that is same as gen, or when I say gen, that's same as use. Similarly, when I say def, that is same as kill, and when I say kill, that is same as def. Okay, so these are synonyms of each other. And this is an important point, that in the live variable analysis, you can see kill and def, they are same, and gen and use, they are same. Consider these examples, these statements. In this statement, tell me what will be the def of s1 and what is use of s1. Okay, you can see this statement I've told here. You can see def of n is same as kill of n, and you can see that use of n is same as ref of n is same as gen of n. So you tell me, in this statement, which statements are killed of s1, killed by s1, or I can say defined by s1, both are same. So tell me which variables are killed by s1. You can see x is defined by s1. Okay, and what is gen of s1, or I can say use of s1? That is basically nothing. We are not using any variable, so we are not generating any variable. Okay, what about this statement? Here you can see what will be kill of s1, s2. Kill of s2 means def of s2, that is basically x. Okay, and remember what is gen of s2? That is same as use of s2, that is basically x comma y. Okay, similarly you can see here what is gen is x comma y, and what is kill, that is basically empty. We are not killing any variable, we are not defining any variable. Okay, what about this instruction? What is gen is x comma y, because we are using x comma y. You can see if x is less than y, then go to l. We are using x comma y, we are not writing x comma y. Okay, and what is kill means which variables we have defined here? We have not defined any variable, we have not written to any variable, so I can say kill and definition, they are same. What about this statement as 5? Here notice one thing, that here this is assignment, yes or no? This is the assignment operator. Here we have assignment operator, and notice here what we have. Is this assignment operator? No, this is a equality operator. This is checking equality, yes or no? This is checking equality. So please understand, here are we defining any variable? Are we writing to x? Here we are not writing to x. Please understand, here we are not writing to x. So if I ask you what is def of s5, then that is basically empty set, because we are not writing to x. We are actually using x. Okay, yes or no? Very simple. So remember, please understand, don't confuse. This is your checking equality operator, and this is the assignment operator. Here we are assigning this value 3 to variable x. Okay, and what about these one? For example, here you can see that we are assigning to x, so we are writing to x, yes or no? So you can notice that here in this statement, what will be def or kill? What that will be? That will be x. And what variables we are using? Use or gen. What variables we are using? We are using variable y. Okay. Remember, a is not a variable. What this instruction means? This is the indexed copy instruction. We have already seen in the 3 address code lecture that this is indexed copy instruction. In this x, we are assigning the value which is present at the location a plus y. Okay, this is the explanation. What about this instruction? In this instruction, is there any variable to which we are writing? We are using y. Also, we are using x. We are not writing to x. Remember, we are writing the value of y to the location a plus x. But actually, we are not writing to x. So here, please understand that there is no variable to which we are writing. So actually, the def, or I can say the kill, that will be actually empty set. Okay, and notice that here, what will be use or gen? That will be x comma y. Both are actually used. X is also used, y is also used. Okay, this is important because some students they can make a mistake that okay, this is on the left side, this is on the LHS, so we are writing to it. No, we are not writing to the variable x. We are reading variable x comma y. Okay, what about this last statement? In the last statement, you can notice if x is equal to 3, this is checking equality. This is again checking equality. Okay, so here also you can see that we are using variable x. We are not writing to variable x, we are using variable x. Okay, so I can say that gen or use, that is basically x. And remember def, that will be empty. Okay, understood? Very simple. So whatever we have seen, that is also written here in this slide. You can notice for different instructions, it is written for those instructions what is the gen set and what is the kill set. Remember, gen set is same as use set and kill set is same as def set. Okay, very simple. So you can see we have seen, I told you that this gen, this is same as def set. Sorry. So this is what we have already seen. I told you that this gen, this is same as read set, or I can say it is basically use set. Okay, you can say read. And kill means assigned, or I can say overwritten. Let's solve this question. Tell me the answer for this question. The kill and gen set for the instruction x, in x we are assigning a plus x. So for this instruction, what is the gen set? Gen means use. Which variables we are using, which variables we are reading. So tell me which variables we are reading. We are reading a comma x. And kill means which variables we are defining. So which variables we are defining? We are defining only x. So for this question, the answer will be option B. Let's solve this question. Tell me the answer for this question. The kill and gen set for the instruction mi, we are assigning this value to the location m plus I. So tell me here, are we writing to the variable I? No, we are not writing to the variable I. Yes or no? So here you can notice which variables we are using, which variables we are reading. So I can say that variable I we are reading, variable A we are reading. And tell me, is there any variable which we are writing to which we are writing? Means what is def or what I kill, what is kill? That is empty set. Okay, so you can see that kill is empty set and gen, that is I comma A. So for this question, the answer will be option E. Now let me tell you a trick to remember. This trick actually we have already seen, but let me explicitly tell you about this trick. For any individual statement, remember, in the forward direction, first use happens, then kill happens. Okay, first read operation happens, then the write operation happens. Very simple. And in the reverse direction, first kill happens and then use happens. So remember, in the reverse direction, first you kill, then you use. Use means generate. Okay, so first you kill, then you generate. Very simple. And remember this live variable analysis, this is a backward analysis. So in the backward direction, remember, first you kill, then you generate. That's it. Now you can handle any individual statement very easily. Consider this example. In this example, let's assume that you don't know what is this in. Okay, this is the statement n, and for this statement n, this out of n is given to us, and we need to find what is in of n. We need to find what is in of n. Okay, so it is very easy to find. Remember, the liveness analysis, the live variable analysis, that is a backward analysis. So you can see this is already given to you, that out of n, that is basically x comma z. And what this statement will do, when you cross this statement, then what will happen? You can see, I told you that first you kill, because in the reverse direction first kill happens, then gen happens, means first you kill, then you generate. So tell me, first whom you will kill? First you kill x. So from here, first you kill x. So remember one thing, that in the reverse direction, when you cross this statement, when I cross this statement, then what will happen? Let me tell you. Let me tell you, when I am crossing this statement, then what is happening? It is happening that first you kill. Okay, so you can see first you kill x. Just first you kill x. Okay, first you kill x, then what you will get? Then you will get z only. Yes or no? From this x comma z, first you kill x. Okay, so then what you will get? Then you will get z. Okay, and then what you do? Then you generate. Okay, then you generate. So what will be generated? Tell me. You can see x comma y will be generated. So now you generate x comma y will be generated. Already there is z. X comma y also will be generated. So you can see x, y, z. So remember the final answer that you will get, that will be x, y, z. Did you understand? This is the trick I told you, and we have already seen why this trick works. This point we have already seen because I told you that when we have x equal to x plus y, then if you can basically think like this, that first you are using in the forward direction, first you are using, okay, and then you are writing. This is in the forward direction, first use then write. But in the backward direction, first we are killing, then we are generating. So first you kill, then you generate. Okay, and remember the live variable analysis, this is a backward analysis. So this is what I'm telling you, that basically in the reverse direction, first you kill, then you generate. Okay, and I told you use means generate. Use means generate. Okay, so I hope you understood this point, that final answer will be x, y, z. Means from this x comma z, when you cross this statement, then what will happen? First this x will be killed. So this x will be killed, only z will be remaining. Then this x comma y will be generated. So finally you will get x, y, z. This is how you can think. Okay, very easy to think, like yes or no. Now let me quickly ask you some questions, and you tell me quickly, give me the answer. Okay, so some statements I am giving you. Also I am giving you what is the out live. You tell me the in live. Okay, so for example, consider this statement x equal to 3. Okay, and remember the out live, that is x comma y. Tell me what will be the in live. Quickly tell me. You can see first you will kill. Okay, when you cross this statement, then first this x you will kill, then you will generate, but there is nothing generated here. We are not using any variable, we are not generating any variable. So finally the answer will be y. Okay, yes or no? Now what about the next? Consider any statement you want to consider. For example, let's assume the statement is x equal to x plus y only, and let's assume this out, this is y comma z. Now you tell me what will be in. What will be in? So remember, from this out, okay, you can see first you kill x. There is no x here, so don't have to worry. So first you kill x, means first you remove x, then you add x comma y. Okay, so finally the answer will be x comma y comma z. This will be the final answer. Okay, next you can notice if you have x equal to x plus y, and let's assume here you have x comma z, then what will be here? So you can see first you kill x, means you remove x, then you generate x comma y. Okay, so you can see x, y, z. Very simple. And similarly, if you have this statement, print x comma y, okay, and let's assume this out is given to you, that is y comma z. So tell me what will be in. Very simple. In will be what? Remember, from here, first you kill, but nothing is killed because in this statement, we are not writing to any variable, we are not defining any variable, we are not killing any variable. Okay, so first you kill, but there is nothing to kill here because this statement is not killing anyone. Okay, so you can see, then you generate. Yes, x comma y will be generated. So finally, x comma y comma z, this will be the answer. Okay, consider this statement, x equal 3. Okay, tell me, here let's assume x comma y, these are alive. So what will be in? Let me know what that will be. Notice one thing here, we are using x, we are not writing to x. Here, please understand that we are using x. Here we are using x, not writing. Okay, not writing x, because this is basically equal. This is not your assignment, this is your equality checking. We are checking equality. Okay, so you can notice that first we will kill, but this instruction will not kill anything. Then we will generate. Yes, here we are generating x because we are using x. Okay, so finally the answer will be x comma y only. Very simple. Let me just give you some more instructions. For example, let's assume your instruction is x of, let's assume your instruction is a of x y. Okay, and let's assume that this out, this is given to you, this is x comma z. So tell me what will be in, what that will be. Very simple. Please understand that here we are not writing to any variable. Yes or no? Here we are using x comma y. Okay, yes or no? And here what we are killing? No, none. Okay, yes or no? So remember, first you kill, but this statement will not kill any variable. Then you generate. X comma y will be generated. So I can say this will be x, y, z. Okay, very simple. I hope you understood all these small points. Consider this next statement, that is like if x is less than y, go to L. Okay, so here let's assume that W is alive here. Okay, so tell me what will be alive here. You can see we are going in the reverse direction. Okay, so you tell me, you can notice here we are using x comma y. We are not writing to any variable, we are using x comma y. Okay, so first this instruction, first it will kill, but this instruction will not kill anything. Then you generate. Okay, in the reverse direction, first you kill, then you generate. Very simple. So finally you will get x, y, w. Okay, very simple. And just last instruction, that is like in x we are assigning 3. Okay, this instruction actually we have already seen. Okay, let's assume here you have y comma z. Okay, then tell me what we will get here. So you can see this instruction, first you kill, then you generate. This will kill x, but there is no x. Okay, so there is nothing to worry. So you can see first you kill x and then you generate, but there is nothing generated here by this instruction, nothing is generated. So it will be y comma z only. That's it. I hope you understood this. Now let's consider the formula. So far we have only used the logic. Okay, you can see for each and every instruction we have only used the logic only. But now can we convert the logic to the formula? Yes, we can do that. Let's see the formula now for individual statement. So you can see if you have a statement n, in this statement n, some variables are used, means some variables are generated and some variables are defined, means some variables are killed. Okay, so let's assume that here you can see some variables are killed. Okay, agree, some variables are killed here and some variables are generated here. Okay, that you already know, that gen of n, that is same as use of n, and you also know that kill of n, that is same as def of n. Okay, so this we already know. Now, if out of n is given to us, okay, here you can see out of n, if that is given to us, then how to find in of n? Can we write some formula for in of n? Out of n is already given to us. Can we write a formula to find in of n? So you can see that in of n, or I can say in live of n, what that will be. In of n, this is also called in live of n. What that will be? That will be equal to, I told you that in the reverse direction, because the liveness analysis we do in the reverse direction. So you are going in the reverse direction. In the reverse direction, first you kill, then you generate. Okay, so remember, from this out of n, first you kill. From this out of n, you remove the kill of n. Okay, means first you remove the variables. First you kill the variables. Okay, from this set of variables, you remove those variables which are killed. Okay, is this clear? So first you kill. After killing, what you do? Then you generate. Means all the variables which are in the gen n, all those variables you do the union. You do the union with gen of n. Union with gen of n. Okay, is this formula clear? Very simple. The proof we have already seen. Did you understand this formula? How did we get this formula? Did you understand? Very simple formula. Remember that from this out of n, you are going in the reverse direction, in the backward direction. Okay, for this instruction, first you will find what is the kill set, what is the generate set. Okay, gen and kill both set you will find. Then to find this in of n, what you will do? From this out of n, first you kill in the reverse direction, first you kill, then you generate. So first you kill, then you take the union with generate set. Okay, yes or no? So this is the formula. So we have seen the formula for liveness analysis for individual statements. And what was our formula? You can see the liveness analysis we do in the reverse direction, in the backward direction. And this statement is given to us and the out live information is given to us. We need to calculate the in live information. Okay. So this in live, this is what we need to calculate. So what we will do, remember, this out live will be given to us. And for this statement, two things we will find. What is that? We will find what is the kill set of n, and we will find what is the gen set of n. And remember, the kill set of n, that is same as def set of n, and the gen set of n, that is same as use set of n. Okay, very simple. So now you can easily find what will be the in live of n. What that will be? Very simple. From this out live, because we are going in the reverse direction, we are crossing this statement. When we cross this statement, we will get the in live of n. So this in live of n, that will be equal to, from this out live in the reverse direction, first you kill, then you generate. Okay, because remember, if you see in the forward direction, first we will use x plus y, we will use x comma y, first we will use them, then we will assign to x. But if you see the same thing in the reverse direction, in the backward direction, then in the backward direction, first we kill, then we generate. Okay, so this is the formula. You can see in live of n, that is equal to out live of n. From this you remove, from this you remove the kill set of n. Means first you kill. Okay, first you kill, and then you take the union with gen. Very simple. First you kill, then you generate. That's it. Okay, in this example, you can easily notice that what we will do here. Tell me. You can see this is the out live. So from this x comma z, first we will kill. Tell me what is the kill set? Here, what is the kill set? The kill set is x. Yes or no? The kill set is x. And what is the gen set? The gen set is x comma y. Okay, so you can see first we will kill, means first we will remove x, and after that, we will take union with gen, and the gen is x comma y. Okay, yes or no? So finally, what you are going to get, you can see the final result that you will get, that will be first x will be removed, you will get z, then you will take union with xy, so you will get xyz. This is what you are going to get. Okay, I hope you understood this. Very simple. Let's solve this question. We already know that live at an instruction means live just before that instruction. This already I told you, because for any instruction there are two program point, one immediately before the instruction, one immediately after the instruction. There is no program point on the instruction. So if some author says that live at an instruction, it means live just before, immediately before the instruction. Okay, now the question is asking find live of n, means for this instruction n you find live at this instruction n. That means we need to find live immediately before this instruction. Okay, and the question is saying assume that at the end no variable is live. Okay, so two statements are given to us, and the question is saying that at the end there is no variable alive, means here it is already given that at this point, at this point you can see nothing is alive. Okay, this is given at the end. You can see the question is saying at the end no variable is alive, so this is already given. Okay, now you can see we will go in the reverse direction, the live variable analysis. This is a backward analysis, we will go in the backward direction. Okay, you tell me, when I cross this instruction, what I will get, means here what I will get, you can notice this is n plus 1, this instruction is n plus 1. Okay, you can see this instruction is n, so the next instruction that is basically n plus 1. So you tell me what will be in of n plus 1, let me know. You can see this is out of n plus 1, and that is given to us out of n plus 1. Here you can see that out of n plus 1, that is given as empty. Okay, so you tell me out of n plus 1 is empty. When I, in the reverse direction, when I cross this instruction written as plus t, here we are using s comma t, yes or no? And remember, this instruction is not defining any variable, so this instruction will not kill anything, but it will generate s comma t. Okay, so notice one thing, that this instruction will generate s comma t, it will not kill anyone. Very simple. Okay, so this is what we got in of n plus 1. And you can easily see this in of n plus 1, that is same as out of n, because this program point, look at this program point, this program point is immediately after n, immediately before n plus 1. Okay, yes or no? So you can notice that this same thing, this is basically out of n. So now we have out of n, that is equal to s comma t. Okay, now we need to find what will be in of n. What will be in of n? That will be equal to the formula. You can apply, either you can apply the formula or you can directly do. Basically, you can see this is the out of n s comma t. From this you kill, first you remove z, then you generate. Okay, you can see from s comma t, if you remove z, there is no z here, so if you remove z again you will get s comma t, and then you generate x comma y. Okay, so finally you can see the final answer that we will get, that will be like this, or you can apply the formula, but the point is this is the out of n minus kill of n. Okay, first you kill and then you union with gen. Okay, and you can see that what is this out of n? This out of n, this is already s comma t, we have already calculated. What is kill of n? That is z. And what is gen of n? That is x comma y. Okay, so the final answer that you will get, that will be stxy. Okay, this is the final answer. I hope you understood this point. Very simple, right? So you can see, and remember the question was asking what is live of n, and this live of n, this is same as what? live at an instruction, that is same as live immediately before that instruction, means this is basically same as in of n. Okay, and that answer we have already got, that is stxy. Okay, so you can see stxy, this is the answer. I hope you understood. So we have seen the live variable analysis for a single statement. We have seen the logic, we have seen the concept, also we have seen the formula. These slides, you can go through these slides. Everything that is written in these slides we have already seen. Okay, you can see the live variable analysis. This is a backward data flow analysis. Okay, and you can see in this live variable analysis, basically we want to check whether at any program point we want to check whether some variable is used on some path. Starting from that program point, some variable is used on some path before it is defined. Okay, this is what we want to check. You can see the variable liveness, it will flow backward. This is a backward analysis. You can see every instruction will have effect on the liveness information as we go in the reverse direction. As we go in the backward direction, every instruction will have effect on the liveness information. When you cross an instruction, then the liveness information will be updated. Okay, and it will depend on that instruction. Very simple. You can easily see this example. This is a beautiful example. You can see this is initially given that, okay, at the end there is no variable alive. Now you can see in the reverse direction you are going, remember, in the reverse direction when you cross this print f, here we are using f, so this f will be generated. Next you can see when you cross this instruction, then d will be killed. First you kill, then you generate. Okay, so you can see from this f you remove this d, already there is no d. Okay, so you can see this f and then you generate, means f comma e. So you can see this f comma e, because here we are generating e and we are killing d. First you kill and then you generate. Very simple. Next you can see when you cross this instruction, then you can see this e comma f. First you kill a, there is no a. Okay, first you kill a, then you generate b comma c. So e f b c, this will be your final answer. We are going in the reverse direction. So this is a beautiful photo. Okay, you can see this photo also. Initially this is given, please understand. Okay, at the end this information will be given at the end, and at the end if no information is given, then you can assume phi, means no variable is alive. Okay, but here you can see it is already given to you that at the end a b c are alive. Why they are alive? Because maybe in the remaining program maybe they are used. Okay, before they are defined they are used. So you can see initially, just go in the reverse direction, initially a b c these are alive. This instruction what it will do, it is defining c, so it will kill. First you kill, then you generate. This instruction will not generate anything, it will simply kill c. So finally you will get ab. Okay, when you cross this instruction, then it will kill this variable c. Now you got ab. When you cross this instruction, it will kill b, you got a. When you cross this instruction, it will kill a, finally you got empty. Okay, very simple. You can see this diagram also, that here you can see this is the, for this instruction print x, this is the out, and so what will be in, you can see this instruction will generate x and it will not kill anything. So this instruction, it is not defining any variable, so it will not kill any variable, but it will generate x. So you can see this is the output, x is generated. Okay, when you cross this print x, then x will be generated, already there is y, so you will get x comma y. You can see when you cross this instruction, then here x will be killed, there was x. Okay, and when you cross this instruction, x will be killed. Okay, only you will get y. Very simple. This photo we have already seen, that in this instruction, remember, first you kill in the reverse direction. When you go, then first you kill, then you generate. So you can see from this x comma z, first you kill x, only z is remaining, then you generate x comma y. So you can see finally you got x y z. Okay, very simple. And we have seen the formula also. You can see this is the formula. In live of n, that is equal to, from the out live of n, you first remove the kill set. Kill set means definition set. Okay, so first you remove the kill set, and then you take the union with the gen set. Gen set is same as reference, or it is same as use. Very simple. Here this example also you can see we have already seen this. Okay. Tell me the answer for this question. Some true false statements. Let's see the first statement. You pause the video, solve this question. For all these three questions, you find whether they are true or false. You write your answer in the comments and then you play this video. Let's see. If a variable var is used in instruction I, used means its value we have read in the instruction I, then this var is live at the entry of I. Tell me, is this statement true or false? The first statement is saying that there is an instruction I, and in this instruction I, we are using variable var. Okay, remember, in this instruction I, we are using this variable var. We don't know about the kill. Maybe var is killed also. Okay, we don't know. So tell me, does it matter? Does it matter whether this variable is killed or not here? It does not matter, yes or no? Because if this instruction has read var, this variable, okay, means this use means generate. Okay, that means read. And you can see that now, if you go in the reverse direction, whatever you have here, whatever out you have here, you can see this in of I will definitely contain var. Yes or no? It will definitely contain var. There can be some other things. Because I told you that if an instruction has generated some variable, if an instruction has used some variable, then remember that variable will definitely belong to in of I. Okay. Or you can apply the formula. You already know that in of I, that is equal to out of I minus kill of I union gen of I. Now you can notice we are taking the union. So already gen of I, it contains var. Okay, yes or no? It already contains var, and you are taking union. You are taking union. So definitely it does not matter. So remember, this event does not matter. Okay, here it doesn't matter. It doesn't matter because you are taking union, and because of this union I can say that definitely, I can say because of this union I can say that definitely here this var belongs to in of I. Very simple. So remember, the first statement, that is actually true statement. Okay, what about the second statement? If var is assigned a value in instruction I and this var is not read in I, then this var is dead at the entry of I. Yes, this statement is also true. This instruction I is killing this variable var and it is not generating this variable var. So this var will be dead at the entry of I. Agree? Very simple. Next, what about the next statement? If var is live at the end of instruction I, then it is also live at the entry of I. Is it necessary? No, this is not necessary. This statement is false. Can you give me a counter example? Yes, I can give you a counter example. See, for the third statement is saying that we have an instruction I, and the third statement is saying that if var belongs to out of I, here var belongs to out of I, then it will also belong to in of I. Is it guaranteed? No, it is not guaranteed. I can give you a counter example. Consider this counter example. Let's assume in this instruction I, let's assume in this instruction I, this is what you are doing, var equal to a plus b. Okay, now you can easily see that when you go in the reverse direction, then here this instruction, when you cross this instruction, then this var will be killed. Yes or no? This var will be killed. Let's assume here you have w. So you can see this var will be killed. Then this a comma b will be generated, because I told you when you go in the reverse direction, then first you kill, then you generate. So first this var will be killed, then this ab will be generated. So you can see this abw you got. So you can notice that var belongs to out of I, but it does not belong to in of I. You can see if var is live at the end of instruction I, then it is also live at the entry of I. This statement is false. It is not necessary. Okay. I hope you understood this question. Very simple. So far we have seen liveness analysis, live variable analysis for individual statement. This we have already done. Okay. Now we will study live variable analysis for basic blocks. Individual statements we have seen how to handle, and now we will see how to handle basic blocks. Then we will study how to handle control flow graph. Okay. So let's study live variable analysis for basic block. Let me tell you, I already told you that for a basic block, there are two program points. From the basic block point of view, there are two program points, one at the entry of the basic block, another at the exit of the basic block. Let's assume this is a basic block. In this basic block, these are the instructions. Okay. Now you can notice that at the entry of the basic block, there is a program point, and at the exit of the basic block, there is a program point. Okay. So remember, for these program points, we define two set of variables. You can see in of b. Let's assume this is the basic block b. This is the basic block b. Now, for this basic block b, these are the program points, one at the entry of the basic block, another at the exit of the basic block. So for these program points, what we do, we define in of b. You can see in of b means this is the set of live variables at the entry point of basic block b. Very simple. And what is out of b? Out of b, this is the set of live variables at the exit point of basic block b. I hope you understood this point. Okay, very simple. So you can see that we define the data flow equations directly in terms of in b and out b, which represents the set of variables live at the points immediately before and immediately after the basic block b. So you can see we have live in b. Remember this in b, you can also call it live in b. You can also call it in live b. Okay, so these are different names, but the point is very simple, that what is this in b? This is the set of live variables at the entry point of basic block b. So you can see live in of b, this is the live variables at the entry point of basic block b. And what is this out b? You can also call it out live b, or we can also call it live out b. Okay, these are basically synonyms. Now you can see what is this out b? This is the set of live variables at the exit point of basic block b. So you can see live variables at the exit point of b. I hope you understood. So these two set of variables we define, or I can say we need to calculate this in of b, and this out of b will be given to us. And remember, we will go in the river direction. The live variable analysis, this we do in the river direction. So very simple point. Remember this out live of b for a basic block, the out live of b, this will be given. So you can see the initially at the end of the basic block b, some variables might be given to be live. Okay, why they might be live at the end of the basic block b? Why some variables initially might be live? Because maybe these variables are used in other basic blocks. Yes or no? So please understand that in a basic block, from a basic block point of view, there are, I told you that there are two program points, one at the entry of the basic block, another at the exit of the basic block. And remember, at the exit of this basic block, the set of variables which are live, that we represent by out of b. Okay, and this is the basic block b. So this out of b, this will be given to us. This will be given to us. And what we need to do, we need to calculate this in of b. This in of b we need to calculate. And how to calculate this? Very simple. We need to go in the backward direction. Okay, the live variable analysis, this we do in the backward direction. Very simple. So remember, this in of b, it will depend on whom? This in of b we will calculate from out of b, also from this basic block b. Okay, so you can see that this in of b, this is a function of out of b, and also remember it will depend on this basic block b, the statements in this basic block b. So very simple. We will see the formula also, don't worry. Now let me tell you, for the live variable analysis for a basic block, there are two methods. Method 1, which is inefficient, not efficient, so we will not use it much. And there is a method 2 which is efficient, so we will use this method 2 a lot. Okay, so let me tell you about the method 1. Let me tell you, most of the students, they actually use method 1, they don't use the method 2, but method 2 is very efficient, as you will see. So let me tell you, when we do live variable analysis for a basic block, then there is a method 1 that is inefficient, that is go statement after statement in the reverse direction. One single pass will be enough. Okay, you can see, in the reverse direction you go, keep crossing all the statements. Okay, statement after statement you keep crossing, just keep going in the reverse direction. Only one single pass is enough, but basically you have to cross all the statements in the basic block. Let's assume there are 10 statements, then it will take a lot of time, because you have to cross all the 10 statements in the reverse direction, statement after statement. This is the method number 1. So in the method number 1, basically you just have to handle one statement at a time. And we have already seen liveness analysis for individual statements, that we have already seen. So this method 1 you can apply for basic block, but this is inefficient, as we will see. There is another method, method 2. In this method 2, what we do, for the whole basic block, we find what is the use of basic block, means which variables are used in this basic block and which variables are defined in this basic block. Okay, so basically for the whole basic block we find these two set of variables. Then what we do, then we consider the whole basic block as a single statement. So even if your basic block has, let's assume, 100 statements, then also this method is very efficient, because the whole basic block we will consider as a single statement, and we will apply the same previous formula that we have seen in the reverse direction. The same previous formula, that is like in of b is equal to, you can see, from out of b, first we will remove the kill, first we will kill, and then we will generate. Okay, then we will take union with the generate set. All right, generate set means use set. So this formula we will apply. Okay, now let's see both these methods one by one. First we will see this method number 1, which is inefficient, but let's see this just for practice sake. So remember, in this method number 1, what we have and what is given and what we need to find. So remember, in this method number 1, a basic block we have. This is the basic block. And in this basic block, this out of b will be given to us. This is the basic block b. This out of b, this will be given to us. Means the variables which are live at the exit of this basic block, that will be given to us. Maybe these variables are used in some other basic blocks. Maybe that is the reason these are live at the end of this basic block. Okay. And we need to find the in of b, we need to calculate. Okay, and in this method number 1, what we will do, we will go in the reverse direction, statement by statement, and we already know how to handle individual statement, that we already know. Okay, and remember, one single pass will be enough. One single pass, that will be enough. You don't have to do multiple pass. Just one single pass of the reverse direction will be enough. Consider this example. You can see, for this basic block, the out of b, this is given to us. Okay, so let's see this here. You can notice that this is our basic block. This is the basic block b, and for this basic block, the information that is given to us, that is out of b, means the set of variables live at the exit of this basic block b, that is given to us. Okay, so you can see this information is given, and what we need to calculate, we need to calculate the in of b, means the set of variables live at the entry of this basic block b, so that we need to calculate. Okay, so in the method number 1, what we will do, we will go in the reverse direction, statement by statement. Okay, very simple. So let's see how to go statement by statement. So tell me, in the reverse direction, when you cross this statement, then what this statement will do, remember, this statement will kill f and it will generate e. Okay, so you can see, when you cross this statement in the reverse direction, when you cross this statement, then first you kill f, we have b comma d. From this you remove f. There is no f here, so nothing to worry. So just generate e, means bde. Okay, so you can notice here what we will get. We will get bde. This is what we are going to get. Very simple. Okay, now let's see the next. When we cross in the reverse direction we are going, when we cross this statement, then here remember first you kill d will be killed and then a will be generated. So remember from here d will be killed, this d will be gone, and then a will be generated. So we will get b a e. This is what we will get. Okay, very simple. Then in the reverse direction keep going. So when you cross this statement, then remember e will be killed, first you kill e and then d will be generated. So here you can notice that b a d. Very simple. Next, when you cross this instruction, then remember d will be killed, first you kill d will be killed, then a comma b will be generated. Okay, so very simple. When you cross this instruction, then c will be killed. There is no c in a comma b, so c will be killed, first you remove c, then you add a. Okay, so again here also a comma b. Next, when you cross this instruction, now a will be killed and b will be generated. Okay, so you can see this a will be killed and you can generate b. So this is the final answer. I hope you understood. So remember, this will be the in of basic block b, where this is the out of basic block b, which is given, which was given, and this we have calculated. I hope you understood this point. Okay, so you can see this was the initial situation and the final answer will be this. Okay, so we are going in the reverse direction, statement after statement. Okay, now let me tell you the method number 2 for live variable analysis of a basic block. There is an efficient method that is very simple. For the whole basic block, first we will define and first we will find use of b and def of b. Then the whole basic block we will consider as a single statement, and then the same previous formula we are going to apply in the reverse direction. The same previous formula, that is in of b, that will be equal to out of b minus def of b. First you remove the kill, first you kill and then you generate. Okay, then you take the union with generate. So you can see first you kill, out minus kill, and then union with generate. Or I can say out minus def is same as kill. Remember, def is same as kill. Okay, so out minus def, and then you take union with use is same as gen. Okay, very simple. Now I need to tell you the definition of def and use for the basic block, yes or no? Because for the whole basic block we need to define what is use of b and what is def of b. Okay, so you tell me, you just tell me that if you have a basic block, then how to define use of b and how to define def of b. Okay, this is the basic block that you have, and for this basic block, let's assume you are standing here. Okay, you are standing here at this point, you are standing. Okay, just focus on this basic block and you tell me how to define which variables will be used in this basic block, which variables are used, how to define that, which variables will be used in this basic block, how to define that. Can I just see the RHS and can I say that all the variables on the RHS they are used? Can I say in this basic block for every statement, can I just look at the RHS and can I say that okay, all the variables on the RHS they will be used? No. When you are standing here, just apply the same definition that we have already seen for the live variable. This is your program point. You are standing here. Okay, so you have taken a binocular, yes or no? Now you are looking at this basic block. So remember which variables will be used. Those variables will be used which are used before they are defined, yes or no? So remember one thing, that use of b, this will contain those variables such that v is used before it is defined, yes or no? Before it is defined. Very simple. V is used before it is defined. If V is used before it is defined, then definitely I can say that this basic block is using using V. Okay, is this clear? So remember, in this basic block, which variables will be used? Those variables which are used in B, which are used in B before it is defined. Okay, very simple. And you can see what will be def of B, which variables are defined in B. For this, you don't have to do anything. Basically, all the variables which are defined. Okay, you don't even have to do anything. Basically, V is defined. Defined means assigned. V is assigned in B. Okay, that's it. So remember, for the def of B in this basic block, which variables are defined, for that you don't have to do anything. For all the arithmetic instructions, just look at the LHS. Okay, so basically all the variables which are defined, or I can say which are assigned, or I can say to which we have written, okay, that will belong to this def of B. But remember, for use of B, you have to be careful. Okay, do not directly take the LHS, RHS. Okay, in all the instructions, blindly don't take the RHS variables, because remember, this variable must be used in B before it is defined. Okay, so very simple point. I hope you understood this. Now, so you can see the definition here. What is def of B? Def of B is the set of variables that are defined in B. Okay, defined means assigned. That are assigned in B. Very simple. That is your def of B. What is use of B? These are the set of variables whose value is used in B before any definition, or I can say before any assignment to that variable. So you can see this definition here. Remember one more thing, that def of B, that is same as kill of B. Okay, these will be the variables which are killed by the basic block B. And remember, the use of B, that is same as ref of B, and that is same as gen of B. These are the variables which are generated by the basic block. Okay, very simple. So you can see what is gen of N. Here N is the basic block. Okay, here N is a basic block. So you can see what is gen of N. Those variables which are used in the basic block N, and they are not preceded by a definition of V. Okay, means those variables which are used in this basic block N before definition of those variables. Okay, very simple. And what is kill of N? This is very simple. Basically, block N contains a definition of V, then those variables you will put in the kill of N. Okay, I hope you understood. We will do a lot of practice, don't worry. But this is the definition. I hope you understood. Okay, so you can see these are the definitions. Def of B, this is the set of variables which are defined in B, and use of B, these are the set of variables whose value is used in B before any definition to these variables. Okay, and just one thing, again I'm telling you that def of B, that is same as kill of B. Okay, and use of B, that is same as gen of B, that is same as ref of B. Okay, so very simple. Now consider this example. These are the basic blocks B1, B2. For these basic blocks, we need to find what is use of B, what is def of B. Okay, so you tell me, for this basic block, what will be use of B? Use of B means which variables are generated by this basic block B. Okay, so remember, you are standing here. Please understand. We are standing here. Now you just tell me, at this point you are standing and you are looking at this basic block, which variables are used? Can I say M is used? Yes, M is used before it is defined. Yes or no? So M is used. N is used before it is defined. Yes, N is used. U1 is used before it is defined. U1 is used. Okay. What about I? No, I is not used. Actually, I is not at all used. J is not at all used. Or A is also not at all used. Okay, so this is the use of B. Tell me, what is the def of B? Or I can say, what is kill of B? That is very simple. That is very simple. That for that you just have to see which variables are defined. You can see I, J, A. These variables are defined. That's it. Okay. Now let's see this b2. In this b2, what is the use of b2? Here this was b1. This was basic block b1. And now let's see the basic block b2. Use means gen, which variables are generated by b2. So which variables are generated by b2? Tell me the variable I is that generated by b2. You are standing here, remember, with the binocular in your hand. You are looking at the block b2. You just tell me this variable I, is it used before it is defined? Remember, here you can notice I is defined also, used also, but you can notice first it will be used. First we will calculate I plus 1, then we will assign to I. So remember, first we are going to use I. Okay, so yes, I is used before it is defined. Similarly, J is also used before it is defined. Okay, so J, very simple. And what about def of B2? That means kill of b2. That is very easy. For that you don't even have to worry, just look at which variables are written to. So I comma j, these variables are written to. Okay, very easy. Consider this example. Here you can see, for this for this basic block, this is the def comma use. For this basic block, this is the def comma use. For this basic block, tell me what will be the def, what will be the use. This basic block we have already seen. Let's see, for this basic block, you can see you are standing here. You can see that a is defined. Okay, and here no variable is used. Okay, maybe a equal to 4, something like that. Okay, maybe here I equal to 7, something like that. So you can see here I is defined and no variable is used. Let's solve this question. So some basic blocks are given to you: basic block 0, basic block 1, basic block 2. And for these basic blocks, we need to find what is the def and use set. So let's see. For this basic block, what is the def of basic block b0? That is same as kill, which variables are killed by this basic block b0. So tell me, that is very easy. Just see which variables are written to. Okay, next you can see what is the use of b0. That is same as ref of b0, or I can say gen of b0. So which variables are used before they are defined? Okay, so tell me, you can see that this I is used before it is defined. First you will use I, you will calculate I plus 1, then you will write to I. So you can see that I is used before it is defined. Okay, what about this? What will be the def of b1? That will be same as, for def of b1 you don't have to do anything, just see which variables, to which variables we have written to. Okay, so you can see that a comma x. And what is use of b1? That means gen of b1. Which variables have we used before we have defined them? Which variables we have used before we have assigned to them? So you can see that variable x we have used before we have assigned to it. What about a? Can I say a? No. You can see that a actually we have not used at all. Okay, next you can see, yes, that's it. So you can see that x is used. Okay, what about this statement? Here you can see the def of b2, that is equal to t. Okay, just see the variables to which we have overwritten. So next you can see that use of b2, that will be equal to a, which variables we have used before we have written to them. Okay, so very simple. Consider this basic block. In this basic block you can see that x has been used, y comma x has been defined. Okay, so y comma x, they are def, and x is in the use. Okay, what about this here? Here you can notice that x is not in the use. Okay, see, look at this example. For this basic block, this is a basic block. Okay, this is a basic block b1, and this is basic block b2. Yes, this example is good example. So let's see. In the basic block B1, actually it is very easy. What will be the def of B1? That is very simple, that y comma x, these are the def of B1. Okay, what will be use of B1? Which variables we have used before we have defined them. So you can see, yes, x we have used before we defined it. Okay, let's see here. This basic block B2, this is interesting. Let's see. So def of B2, which variables we have defined? That is very simple, x comma y. You don't have to think. Okay, but here you notice that what will be use of B2? What will be use of B2? You can notice the variables which we have used before they were defined. Notice x has been used, but before that we have defined it. So please understand that there is no variable which we have used. Okay, is this clear? So this is an interesting point. Notice one thing here, that in this basic block we have not used variable x. Is this point clear? Because you are standing here and you can notice that in this basic block we have not used variable x, because before using variable x we have assigned to it. Okay, so I can say that in this basic block we have not used this variable x. So I can say use set of this basic block, that is basically empty. We have not used any variable. I hope you understood. Now remember, now let's come back to our method 2. I told you this is the liveness analysis for a basic block. I told you the method is very simple, that for the whole basic block we will find what is use of b, what is def of b, and then we will consider the whole basic block as a single statement and we will apply the same previous formula. Okay, so remember, now the question will give us a basic block. In this basic block there can be many statements, one or more than one statements can be there, and in this basic block this out of b means the variables which are live at the end of this basic block, that will be given to us. Okay, and the question will ask us what is the in of b, means at the entry point of this basic block b, what is the set of live variables. Okay, so this is what the question will ask us. So let me tell you, you don't have to go statement by statement, you don't have to do that. What we will do, for this entire basic block we will find what is def of b. Okay, this is what we will find. We will find what is use of b, this is what we will find, and then we will use this formula, that in of b, that is equal to what? That is very simple, go in the reverse direction. In of b, that will be equal to out of b minus def of b, because first you kill, basically first you remove the def of b. So you can see that this is the formula that you already know, out of b minus kill of b. Kill of b is same as def of b. Okay, so basically you do this, first you kill, then you generate, then union generate. Okay, very simple. I hope you understood this point. So this is the method that we are going to apply. But remember, you must understand the use of b and def of b. Okay, so remember, for this set, for this basic block, you tell me what will be the use of b, which variables are generated by this basic block b. Tell me which variables are generated. Remember, use of b, that means those variables which are used before they are assigned some value. Yes or no? Before they are assigned, before they are defined, they are used. So you can see that you are standing here. Now you can notice b comma c, they are used before they are defined. What about a? You can see a is used, but before that a is assigned. So remember, I can say overall that a is not used by this basic block b, or I can say that a is not generated by this basic block b. So please understand, a is used here, but a is defined before use. So this use of b, it will not contain a. Okay, what about the next variable d? Yes, you can notice that here d is assigned, also d is used, but you can see first we will use d, then we will assign d. So remember, d is also there. Okay, what about e? You can see that yes, e is also used before it is assigned. So yes, e. I hope you understood. And remember, def finding is very easy. For that you don't have to do anything. Def of b or kill of b, that is very simple. Just see to which variables we have written some value, to which variables we have assigned. So you can see that is actually very easy. A, B, D, that's it. Okay, I hope you understood. Now let's consider this example. This example we have already considered Here you can notice that we have a basic block. This basic block we have, and for this basic block already what is given, this out of b, this is given. Okay, you can see this is the out of b that is given to us, and we need to find what is in of b, means the set of live variables at the entry point of this block b. Okay, you can see this is what we need to find. So remember, we will not go statement by statement, we will not do that. Okay, so what we are going to do, something smart we will do. What is that smart thing? So for this basic block we will find what is use of b, and we will find what is def of b. Yes or no? So use of b means the variables which are generated by this basic block b, and also we will find the variables which are defined, or I can say killed, by this basic block b. Okay, so you can see finding the def of b, that is actually very easy. Just see the variables to which we have assigned. So you can see that a, c, d, e, f. Okay, that's it. Okay, so this is actually quite easy, nothing to do here. Okay, but you can see, to find the use of b, the variables used in this basic block b, so basically you are standing here. Okay, so remember those variables which are used in this basic block, those variables which are used before they are defined. So you can see that this b, this is used before it is defined. What about a? You can see a is used, but a is defined first. Okay, before the use a is defined, so I can say a is not generated in this basic block b, I can say. Okay, next you can see a, b, c. What about c? You can see c is also defined before it is used. What about d? D is also defined before it is used. What about e? E is also defined before it is used. What about f? F is also defined before it is used. Okay, so you can see that this is, that's it. So you can see this is the gen of basic block b. So basically in this basic block b, only the variable b is generated. Okay, I hope you understood. So remember, finally for this basic block what we have found, we have found the def of b. The def of b we have found, that is a, c, d, e, f. Okay, this is what we have found. Also we have found the gen of b, that is simply, that's it, b. Okay, that is only b, that's it. Okay, so tell me what will be in of b. Now you can notice you don't have to go statement by statement. What will be in of b? That is very simple, that will be out of b. This is out of b minus def of b, then you take union with gen of b. Okay, so you can see from b comma d, if you remove this, then what you will get, tell me. This is the set difference from b comma d. If you remove a, c, d, e, f, okay, then what you will get, you will get those variables which only belong to this, which do not belong to this. Okay, so you can see that here you can notice this d will be removed, but okay, only b will be remaining. Okay, so you can see that this in of b, that will be equal to out of b minus def of b. Okay, and then union gen of b. So finally the answer you will get, you can see this will be only b and this is also b. So b union b, that is only b. Okay, so the answer will be b. I hope you understood this point. So did you like this method? Because in this method we are not going statement by statement. For the whole basic block we are finding what is def of b, what is gen of b, and then we are just applying the same old formula that we have already seen when we were discussing live variable analysis for individual statements. I hope you understood this, and I hope you loved this method. Okay, you can see the final answer we already got. Let's consider this example. We have a basic block and we need to do the liveness analysis for this basic block. Here you can notice it is not given that at the end of this basic block which variables are live. So when it is not given, then by default you can assume that no variables are alive at the end of this basic block. Okay, is this clear? So remember, here let's assume that here nothing is alive. Let's assume this is already given to you. Means if you consider that, okay, yeah, this is your basic block b, Then remember, already the question is saying that out of B, that is empty. No variable is alive at the end. Okay, at the end of this basic block. Very simple. And again, we need to find what is the in of B. Okay, again, we need to find what is the in of B. Very simple. Now let's see. There are two methods, as I told you. The method number one, which is inefficient, we go statement by statement in the reverse order. Okay, and we already know how to handle individual statements. So you can see initially this is empty. When we cross this statement, tell me what will be the set of live variables. You can see in the reverse direction, when you cross this statement here, this y3 we are using. Okay, and we are not killing anything. So that's it. Okay, only y3 we are using, we are not killing anything. When we cross this statement, when we cross, then what will be the set of live variables? You can see this statement is killing y3. First you kill y3, then you generate y2 x3. Okay, then you generate y2 x3. Very simple. Then what next? You can see when we cross this next statement, what we will get? You can see this instruction will kill y2. First you kill y2, then you generate x1 x2. Okay, so remember, x1 x2 generated, and we have killed y2. Very simple. What about the next? You can see when we cross this instruction, then remember this x3, first you kill x3, then you generate x1 x2. So you kill x3, then you generate x1 x2. Okay, next you can see when you cross this instruction, then first you kill x2, this x2 you kill, and you generate x1. Okay, and then finally at the top, you can see this is the in of B. What we will get? You can see you just kill x1, and we are not generating anything. You just kill this x1 will be killed. Okay, so you can see in of B is also empty set out, and you can see out of B, that is also empty set. Is this clear? So I hope you understood. Very simple. Now let's see what is the method number two. In the method number two, we do not go statement by statement. So tell me what we are going to do. You can see this out of B that is given to us. Okay, and we need to find what is in of B. So what we will do for this basic block, we will find what is use of B. Use of B means gen of B, which variables are generated by this basic block, and which variables are defined by this basic block, or I can say which variables are killed by this basic block. So tell me which variables are defined. That is very easy. Just see the variables to which we have assigned some value. Okay, so you can see that to x we have assigned, to x1 we have assigned, to x2 we have assigned, x3 y2 y3. Okay, x3 y2 y3. Okay, so this is the def of B. Next, what about the variables which are used? Okay, so you can see you are standing here. Now tell me the variables which are used before they are defined. So you can see that x1 is used here, but before that x1 is already defined. You can see x2 is used here, but before that x2 is already defined. You can see x3 is used here, but before that x3 is already defined. What about y1, y2, y3? You can see y2 is used here, but before that y2 is already defined. Okay. What about y3? Remember, y3 is used here, but before that y3 is also defined. So you can see that this is simply empty set. Okay, yes or no? This basic block has not generated any variable. I hope you understood this point. Very simple, because remember here y3 is used, but before that y3 is already assigned. Okay, so now you just apply the formula. What will be in of B? In of B, that will be equal to out of B. From this out of B, you remove the kill set. From phi, if you remove anything, you will get phi. Okay, remember phi minus anything. It's like, because this is phi, right? This is phi. Phi minus def of B. Phi minus def of B. Then you take union with gen of B. Okay, so phi minus anything, that will be phi. Union, what is gen of B? That is already phi. Phi union phi, that will be phi. Means basically that in of B, that is also empty set. Okay, so like this you can do. Very simple. I hope you understood. Now let's see a note inside a basic block between two consecutive instructions. Let's assume that instruction n comma n plus 1, these are any two consecutive instructions within a single basic block. So let's assume there is some basic block, and in this basic block any two consecutive instructions you can take, like first and second, or you can take the last two, or you can take the middle two. Basically any, you can see any two consecutive instructions you can take in this basic block. Okay, so let's assume that this instruction n, this is the instruction in the basic block, and there is n plus 1, this is the instruction in this basic block, and these are consecutive instructions. Now just let me ask you one thing. For this instruction n plus 1, if I ask you what is in of n plus 1, then tell me what that will be. Means in of n plus 1 means, remember, for every instruction there are two program points, one immediately before it, one immediately after it. Similarly, for this instruction also there are two program points, one immediately before it, one immediately after it. But can you notice that, this is in of n plus 1, and this is out of n? Yes or no? That's it. So this is the important point that I wanted to tell you. This is a very easy point. You already understand this when we were discussing program points. Okay, then also we have already seen this, but again we have written this point here. So you can see that if these are two consecutive instructions, then you can notice the out of n means the set of live variables immediately after n, that is same as set of live variables immediately before n plus 1. Yes or no? Because you can see for these two instructions this program point is common. For this program point we have this, for this instruction this program point we have, for this instruction this program point we have, and that is common program point. So you can see that in of n plus 1, that is same as out of n. Okay, is this point clear? Very easy point. I hope you understood. Let's see another note. In a basic block, what do you think what happens for the first and last instruction? Because the first and last instruction, they are somewhat, they have some special property. Okay, let's understand. You can see, let's assume this is a basic block, and in the basic block let's assume this is the first instruction in this basic block, and this is the last instruction in this basic block. Okay, and this is our basic block B. You can notice what are the program points from the basic block point of view. There is a program point at the entry of the basic block, and there is a program point at the exit of the basic block. Yes or no? This is from the basic block point of view. So I can say that from basic block point of view, I can say this is the in of B, and you can see this is the out of B. Okay, and what about from the instruction point of view? You can notice this is the first instruction of the basic block. So for this instruction, there are two program points, one immediately before it and one immediately after it. Yes or no? So there is a program point here and there is a program point here. So can you notice that? Again, this program point is common. So remember, in of B, that is same as in of IF. Is this point clear? Means for any basic block, the in of B, that is same as in of the first instruction of that basic block. And similarly, you can notice for the last instruction, there are two program points, one before it, one immediately before it, one immediately after it. And again, the same thing you can notice here, that this program point is common. Means for this basic block, the out of B, that will be same as out of the last instruction of this basic block. Tell me, did you understand this? Very simple point. Okay, I hope you understood. Just look at the program points. So whatever we have seen that is written here, I hope you understood. So we have seen the live variable analysis for individual statements. We have also seen the live variable analysis for basic blocks. Now we need to study the live variable analysis for control flow graph. In the control flow graph also, without loop and also with loop. So let's study now. Now we will study live variable analysis for a control flow graph CFG. Let's start. So let's study liveness analysis, live variable analysis for a control flow graph. Before we study, let me do some recap of some concepts that we need. So let's see what is successor and predecessor of a basic block in the control flow graph. When we were discussing control flow graph in that lecture, already we have seen what is successor and predecessor of a basic block. But let's see the definition. For a basic block B, what is what is predecessors of this basic block B? So basically the set of basic blocks that are immediate predecessors of B in the context free graph. Sorry, in the control flow graph. Sorry. So for a basic block B, what are the predecessors of basic block B? This is set of basic blocks that are immediate predecessors of B in the CFG, in the control flow graph. And what is successors of B? These are the set of basic blocks that are immediate successors of B in the CFG. And also remember, for the entry node, there is no predecessor, and for the exit node, there is no successor. Okay, very simple. So let me tell you what is predecessor and successor for a basic block B. So for a basic block B, predecessor of B, that means those basic blocks B dash, those basic blocks such that there is a edge from B dash to B. Okay, from B dash to B, there is a edge. Okay, so these are the predecessors of B. And what are the successors of B? The successors of block B, these are those basic blocks such that from B there is edge, from B there is edge to B dash. Okay, very simple. So this is the definition. So basically there should be edge, I can say. For a basic block B, what are the predecessors? These are those basic blocks such that there is a edge from these basic blocks to B. And what are the successors of block B? These are the basic blocks such that from B there is a edge to these basic blocks. Okay, consider this example. In this example, let's assume this is the basic block B1, this is basic block B2, basic block B3, and let's assume B4 and B5. Okay, let's assume this is the basic block numbering. Now you tell me what are the predecessors of B1? Predecessors of B1, these are those basic blocks from which there is a edge to B1. So you can see there is a edge from B5 to B1. Okay, so B5 is a predecessor of B1. Okay, there is no other basic block from which there is a edge to B1. Okay, next, what are the successors of B1? Successors of B1, these are, you can see, successor of B1 means those basic blocks such that there is a edge from B1 to those basic blocks. So you can see from B1 there is a edge to B2 and B4. Okay, so B2, B4. Very simple. I hope you understood. Tell me what about B5? Let me know what are the predecessors of B5. The predecessors of B5 means those basic blocks from whom there is a edge to B5. So you can see from B4 there is a edge to B5. Okay, and what about successors of B5? Let's see successors of B5. So you can see those basic blocks such that from B5 there is a edge to these basic blocks. So you can see from B5 there is a edge to B3. Also there is a edge to B1. Okay, so there are multiple successors of B5. Okay, next you can see what about B3? What about B3? What are the predecessors of B3? Predecessors of B3, these are B2, B5, because from B2, B5 there is a edge to B3. And what are the successors of B3? You can see there is no successor of B3. Okay, there is no edge from B3 to any basic block, so there is no successor of B3. I hope you understood this point. And what about B2? For B2, the predecessor is B1 and the successor is B3. Okay, so you can see that what is the predecessor of B2? So that is basically B1. And what is successor of B2? That is basically B3. Okay, successor of B3. Successor of B2, that is B3, and the predecessor of B2, that is B1. So I hope you understood this point. And what about B4? The predecessor is B1 and the successor is B5. Very simple. Now let's consider this control flow graph. In this control flow graph, tell me, what about B6? What are the predecessors of B6 and what are successors of B6? You can see the predecessors of B6 means those basic blocks from which there is a edge to B6. You can see there is a edge from B6 to B6. So remember, B6 is also predecessor of B6 because there is a edge from B6 to B6. The self loop we have. So remember, predecessor of B6, that is B6. Okay. Also, you can see from B5 there is edge to B6. So B5, this is also predecessor of B6. Okay. What about successor of B6? You can see from B6 to B6 there is a edge. So B6 is successor of B6. Okay. And there is no other basic block to which there is a edge from B6. Okay. So you can see this is the successor of B6. Successor of B6 is B6 only. Okay. What about B3? Tell me, what about B3? For B3, what are the predecessors? And for B3, what are the successors? So let's see. You can see for B3, the predecessor is B3 also because there is a self loop. From B3 to B3, there is a edge. Okay. And you can see B2 is also predecessor because from B2 also there is a edge to B3. That's it. What about successor? From B3, there is a edge to B3. So this is successor. B3 is successor of B3. Next, you can see from B3, there is a edge to B4. Okay. So that's it. I hope you understood. Similarly, you can see what about B4? What are the successors and what are the predecessors? So you can see for B4, the predecessors are, you can see B3 is a predecessor. That's it. There is no other predecessor. Next, what about B4? The successor. Sorry. The predecessor is, for B4, the predecessor is B3. And what about successor? The successor is B5 and you can see from B4 there is a edge to B2. So you can see B5 and B2. Okay. From B4, there are two outgoing edges, one to B2, another to B4, another to B5. Okay. So that's it. I hope you understood this point. Very simple. Now let me tell you some more terminology. This is not important, but this is given in almost all the standard resources. Okay, so let me just tell you, this is a very simple terminology. That is, what is a branch node? Remember, in a control flow graph, in a CFG, the node are the basic blocks. So what is a branch basic block? I can say, what is a branch node? This is a node that has more than one successor. And what is a join node? This is a node that has more than one predecessor. For example, consider this node. You can notice that here we are branching. Yes or no? This is called branching. Do you agree with me? From A, we are branching. So remember this basic block, which has more than one successor. This basic block is called branch node. So please understand that this will be called branch node. Okay. And you can see that these two are joining here. Yes or no? You can notice these two are joining here. So this is called join node because this has more than one predecessor. Okay. So remember this is called join node. I hope you understood this point. And this branch node, this is also called split node because here we are splitting. And you can notice here we are joining. So this join node, here we are joining. And this branch node, this is also called split node. This is also called split node, or you can call it branch node. I hope you understood this point. Consider this example. Here, tell me which basic block is branch node and which basic block is join node. So you can see here we are branching, yes or no? So this basic block has more than one successor. So please understand this basic block is branch node. This is also called split node. Okay. And what about join node? Join node is a basic block which has more than one predecessor. You can see this basic block has more than one predecessor, or I can say, you can see this is like we are joining here. Okay. We are joining like this. So very simple that this is your join node. I hope you understood. So you can see here what is a basic block which has multiple predecessor, that is called join node. And what we call a basic block which has multiple successor, that is called a split node or branch node. Okay, so very simple. What is a join node? It has more than one predecessor. And you can see what is a branch node. Branch node has more than one successor. I hope you understood. So very simple. Now let's see successor and predecessor of an instruction. So far we have seen successor and predecessor of a basic block. Now what about instruction? We can define successor and predecessor for an instruction in a similar natural way. Okay, for example, if you have an instruction here, let's assume this is some instruction n, and you have a next instruction is n plus 1. Okay, this is the next instruction. Let's assume they are in a basic block. Okay, they are in a basic block. Let's assume this is a basic block. Okay, so here this is a basic block. In a basic block, these instructions you have. Now here I can easily say that what is the successor of n for this instruction, what is the successor, and for this instruction what is the predecessor. So you can easily see that the successor of n, here n is the instruction, remember. So you can see here the successor of n, that is your n plus 1. Okay, there is only one successor because this is a basic block. In a basic block we have a straight line flow, yes or no. So all these instructions, they will execute in this sequence. Very simple. What about the predecessor of n plus 1? Predecessor of n plus 1, that is n. Okay, yes or no? Very simple. So I hope you understood that if you have consecutive instructions in a basic block, then remember, for this instruction I can say the next instruction in this basic block, that is a successor, and for this instruction I can say the previous instruction in this basic block is the predecessor. Okay, and remember, if this is the last instruction, then what can happen? Just tell me. If let's assume this is the last instruction, let's assume il, this is the last instruction, then tell me what can happen, how many successors this instruction can have. Now it can have multiple successors, yes or no. Now it can have multiple successors, but remember, for the last instruction the predecessor is only this instruction, there is only one predecessor. What about this first instruction? Let's assume this is the first instruction. For the first instruction, this is the only successor, but what are the predecessor? You can see there can be many predecessor. Okay, I hope you understood this point. Very simple. So all these points are written here, you can read this. You can see, except first instruction in any basic block, except the first instruction, you can see each instruction has exactly one predecessor. Is this statement true? Think about it. Except the first instruction in any basic block, each instruction has exactly one predecessor. Yes, because the first instruction can have one or more predecessor. Except the first instruction in any basic block, every instruction has exactly one predecessor. Similarly, except last instruction in any basic block, every instruction has exactly one successor, because the last instruction can have one or more successor. Okay, so you can see, except last instruction in any basic block, each instruction has exactly one successor. Next, you can see the first instruction of any basic block can have one or more predecessor, and the last instruction of any basic block can have one or more successor. Okay, easily you can understand these points. I hope you understood. Okay, now let's see the live variable analysis for the context free. By context free control flow. Now let's see the live variable analysis for CFG, control flow graph. Here you can see I have taken this situation where basic block has multiple successor. Consider this basic block. This basic block has multiple successor. Let me call this basic block B, and you can see here there is a basic block, let's call it B1, and here there is a basic block, let's call it B2. Okay, and remember, here we have already given what is in of B1. What is this? This is the in of B1. And what is this? You can see this is in of B2. Means at the entry point of B1, these are the live variables, and at the entry point of B2, these are the live variables. And I want to find what will be the live variables here, means out of b I want to find. Can anyone help me? Out of b I want to find. Did you understand the question? You can notice we are doing the liveness analysis for the CFG, for the control flow graph. And this situation I have taken where we have a basic block with multiple successor. Here you can see this is the basic block which has multiple successor. For this basic block B, this B1 is a successor and B2 is a successor. Okay. Now you can see already it is given what is in of B1. At the entry point of B1, what are the live variables? At the entry point of B2, what are the live variables? This is given to you. Now, can you find what will be out of B? This is the out of B. Just use logic. It's just pure logic, let me tell you. Use the definition of live variable at a point, at a program point. Tell me, if I want to check which variables are live at this point, then where should I stand? Let me know. I want to check which variables are live at this point. So where should I stand? I should stand here. Very good. Okay, so remember I am standing here. I am standing. Okay. Now at this point means I will start from here. Please understand. I will start from here. Starting from here, when can I say a variable is live? Starting from here, I can say at this point a variable is live if I start from this point and there is some path where that variable is live, or I can say where that variable is used before defining. Just apply the definition of live variable at a program point. So we are standing at this program point. I told you that at any program point which variables are live, how to find it? Very simple. You start from that program point, and if there is some path, at least one path where that variable is used before redefining, where that variable is used, then I will say that that variable is live at this program point. Okay, yes or no? That definition we already know. You can see the live variable definition. You can see we call a variable x live at a point p if there is some path, at least one path starting from p, where x will be used before redefinition. Okay, yes or no? Very simple. So here also the same thing here. I can say, tell me some path. You can see I am standing here. I can see here that these variables are live, B, C, D. Okay, and here I can say that A, B, C, D are live. So tell me overall, at this point, which variables are live? That will be union. I should take union because at least one path is enough to make a variable live. Okay, you can see at this path, if I go, then here I will see that, okay, B, C, D, these are live. Means, okay, if I start from here, these variables are live. What it means? It means that they are used before they are redefined on this path. Similarly, if I go in this direction, then I will see that these variables are live, means these are used before they are redefined. So I can say that at this point, which variables will be live? That will be union. Okay, do you agree with me? So remember, I will take the union of in of B1, union in of B2. This will be the answer. I hope you understood. So I will take the union and I will get A, B, C, D. This is what I will get. Did you understand this? That I am going to take union. Very simple point. I hope you understood. So please understand this is the important point, that to find out of B, okay, to find out of B, here you can see we have out of B here, and this is the in of B1, this is the in of B2. Okay, so you can see to find out of B, what we will do? We will take the union of in of the successor basic blocks. These are the successor basic blocks, yes or no? So I will take the union of in of the successor basic blocks, and that will be our out of this basic block B. I hope you understood this point. Very simple. So remember, what is the out live of B for a basic block B which has more than one successor? Let me make a diagram to make it clear. Let's assume there is a basic block B. This is the basic block B. Okay, and you can see this has more than one successor. Let's assume this has successor b1 here, this has successor b2 also, and there are many more successor. Okay, successor b3 and so on. Let's assume there is a successor bn. Okay, these are the successors. Now you can see, if this in of b1 is given, in of b2 is given, if these are given, means in of bn is given, and we want to find what is out of b. Okay, we need to find what is out of b. This is what we need to find. Then what we need to do, we just need to take the union of in of all the successor basic blocks, yes or no. So you can easily see that out of b, that will be the union of all the in of all these successor basic blocks. So I can say just take the union of in of bi. Okay, very simple, where this I is going from 1 to n. Okay, because you can see that these are the, basically I have taken, what I have done, remember here I have done the union of in of successor basic blocks. Okay, in of successor basic block, where b is a successor basic block, in of all b's, in of, I am taking union of in of all bi, where bi is a successor of b. Bi, this is a successor of b. I hope you understood this point. Okay, very simple. You can read this line. A variable is live at the end of basic block b if it is live at the beginning of one or more successor blocks. Yes or no? Very simple. For this basic block, a variable is live at the end of this basic block if that variable is live at the beginning of one or more successor basic blocks. Okay, is this clear? Please tell me. Very simple point. You can consider this example. This is our basic block b, and these are the basic blocks b1, b2. You can notice this is the in of b1, and you can notice this is the in of b2. Okay, so how to find out of b? That will be union of these two. So finally you will get xyz. Okay, similarly you can notice this is the in of b1, this is the in of b2, this is the in of b3. Okay, and you can see that how to find the out of b. This is out of b, that will be the union. Okay, to find out of b, just do the union of in of all the successor basic blocks. I hope you understood. So you can see this is the formula. You can see this question, you can read that for any basic block which has successors b1, b2, bn, then what is the relationship between out of b and in of b1, in of b2, in of bn? This is the question. So for this question, what is the answer? Answer is very simple. A variable is live at the end of a basic block b if it is live at the beginning of one or more successor blocks. Okay, so you can easily see that what will be out of b, that will be union of in of all the basic blocks which are successor of b. Okay, very simple. I hope you understood this point. Let's consider this example. Here we have taken basic block with single successor. Now let's consider the next situation. Now we have taken basic block with single successor. Consider this basic block, it has only one successor. Consider this basic block, it has only one successor. So now we have taken basic blocks with single successor. So consider that this is basic block b1, and let's consider this is the basic block b2. Okay, and you can see there is a basic block here. Let's call it basic block b3. Now already this in of b3 is given to us. You can see what is this? This is in of b3, means at the entry point of b3, what is the set of live variables? That is a, b, c, d. This is given to us. Now just tell me what will be out of b1 and what will be out of b2. Can you tell me what will be out of b1 And can you tell me what will be out of B2? Let me know. Very simple. Now you can see B1 has only one successor. Ultimately, if you have many successor, then what we will do? We will take the union of in of all the successors. Yes or no? Here only one successor is there. So that's it. This itself will become the out of B1. Yes or no? You can easily notice here that the live variables at the entry of B3, okay, these are same as the live variables at the exit of B1. Okay, you can see because there is only one successor. So the variables which are live here, these will be live here also. I hope you understood this point. Remember, if this basic block B1 has many successor, then what we will do? We will take the union of in of all the successor blocks. But here you can see this basic block B1 has only one successor. So this itself will become the out of B1 because there is nothing to take union. Okay. So this will become out of B1 and similarly this will become out of B2. So please understand that out of B1 that will become that will become your in of B3. Okay. Also similarly remember out of B2 that is also your in of B3. I hope you understood. Very simple. Okay, this is very similar. This is similar case to the previous case. In the previous case, the basic block was having many successors. So if the basic block has many successor, then we will take the union of in of all the successor blocks. Here the basic block has only one successor. So this itself will become the out of B1 and also this itself will become the out of B2. I hope you understood this. Very simple. So remember, let's write this point that if you have a basic block, let's assume you have a basic block B and this has only one successor B1. Okay, means this is the only successor of B. I can say that when you find the successor of B, then there is only one successor, that is B1. Now in this situation, it's very simple. It's very simple point. It's very, you can easily see the obvious point. Okay, you can just see here that because this for this basic block B, this is the only successor B1. So I can say that these two program points, these are basically same. These has become same. Okay, so I can say that this is your in of B1 and what is this? This is your out of B and these will become same. Okay, out of B will become same as in of B1. Okay, I hope you understood this. Very simple. Let's solve this question. Find in of B1. We need to find in of B1. Let me tell you that here this is the basic block B1, this is B2, this is B3, and this is B4. These are the basic blocks. Now the question is saying that you find in of B1, means we need to find this in of B1. Assume that out of B4 is 5, means already the question is saying that here the out of B4 that is empty, means at the exit of block B4 there is no variable live. Okay, now let me tell you, here the control flow graph is given to us and we need to do the liveness analysis of this control flow graph. Let me tell you, here there is no loop. Yes or no? In this control flow graph there is no loop, and when you have a control flow graph without loop, then let me tell you how to do the liveness analysis. This is very simple. You just do a single pass in the backward direction. That's it. Go in the backward direction, a single pass is enough. That's it. Okay, so remember, already you can see here this out of B4, this is already given to you, this is empty, and these are the basic blocks B1, B2, B3, B4. Okay, and the question is asking what is in of B1. So as I told you, because this control flow graph, this CFG has no loop. Okay, this is without loop. So remember what we need to do? We just need to do single pass in the backward direction. That's it. Okay, so let's do the single pass in the backward direction. So here this is empty set. When we cross this instruction, means here what we will get? Tell me quickly what we will get in of B4. What that will be? That is very simple. In of B4, for this basic block, we just need to handle this basic block. So what we will do? Remember, from this out of B4, we will remove the kill set and then we will generate. First we will kill, then we will generate. So you can see from this empty set, we will remove A and then we will add B comma C. So you can see this B comma C we will get. Very simple. Okay. So that's it. So remember at this point, we got B comma C. This is what I got. Okay. Now you can notice one thing, that for this basic block B2, there is only one successor, this B4. And for this basic block B3, there is only one successor, that is B4. So now you tell me what will be out of B2? What will be out of B2? You can see for this B2 means I am asking this. Okay, what will be the set of live variables here? So you can see because there is only one successor, that is B4. So I can say this will be same as in of B4. Okay, so remember this will be same as in of B4 means B comma C. So here I got B comma C. And similarly, you can see for this B3 also there is only one successor, that is B4. So I can say out of B3 that is same as in of B4. So I can say it will be B comma C. Very simple. Okay, very easy. We are going in the backward direction. A single pass is enough. Okay, now tell me what will be this in of B2 and what will be in of B3. So let me know what will be in of B2. What that will be in the opposite direction, in the backward direction. When you cross this statement, then B will be killed and nothing will be generated, because in this statement we are not using any variable, we are defining variable B. So remember this B will be killed. Okay, so I can say that in of B2 that will be only C. So here you got C. What about in of B3? What that will be? You can see when you cross this statement in the reverse direction, then B will be killed. Okay, so here also you will get C. Very simple. Now you notice what will be out of B1. Just tell me this point. Out of B1. Remember, there are multiple successor. For B1, there are multiple successor. So what we will do? We will take the union of in of all the successor blocks. Yes or no? So you will take union, means you will take this C union C. And remember C union C, that itself will be C only. So we got C. So remember, please understand, here we got C. Now, when you cross this instruction, then what will happen? Here, remember, we are not writing A, we are using A. Okay, yes or no? We are not defining A, we are not assigning to A, we are using A. Okay, so I can say that what will be in of B1? In of B1, that will be, here you can see nothing is killed. This instruction is killing no variable. Okay, so I can say that A is actually generated. So I can say that it will be A comma C. So the answer will be A comma C. I hope you understood. Very simple. Now let's see the conclusion. All the points we have already seen. Now let me tell you the conclusion. You can see the conclusion for calculating out live. Out live for a basic block B or for an instruction I with only one successor. Okay, if you have only one successor, then how to calculate out live? So this we have already seen. If you have a basic block, let's assume there is a basic block B, and here you have a basic block B1. And remember, for this basic block B, there is only one successor, that is B1. Okay, if you find the successor of B, that will only be B1. Okay, so just tell me quickly, if you know the in of B1, if you know the in of B1, then can you find the out of B? Can you find out of B? Yes, out of B will be same as in of B1 because there is only one successor. If you have many successor, then we will take the union of in of all the successor blocks. Yes or no? But here you have only one successor, so very easy. So you can see that these two program points are basically same, I can say. Okay. Because of only one successor, these two program points, they have become same. Okay, now let's see. If you have instruction with only one successor, let's assume there is an instruction N. This is an instruction. Okay, this is an instruction. So let's assume there is an instruction N, and this instruction has only one successor. Okay, there is only one successor. Now you can see Tell me if there is only one successor. I told you that for every instruction there are two program points, one program point immediately before, immediately after. Similarly, for this instruction also there are two program points, one is immediately before it, one is immediately after it. So can you notice these two program points, they have become same. Okay, so this we have already seen that when this instruction has only one successor, then in this situation I can say that what will be out of n, what will be out of n, that will be same as in of n plus 1. Okay, very simple. So this is the conclusion. Easy. Now let's see the conclusion. The concept we have already seen. Now let's see the conclusion. If a basic block has more than one successor, then what we are going to do? Just let me make the diagram. So let's assume this is a basic block B, and this has many successors like B1, like B2, like B3, okay, and so on. So let's assume these are the successors. You can see like these are the successors. Okay. Now, in this situation, how to find out of B? This. We want to find out of B. How to find this? Let's assume that in of B1 is given, in of all the successor blocks is given to us. Okay, means this in of B3 we have, in of B1 we have, in of B2 we have. Okay, so finally I told you this, that out of B, that will be equal to what? That will be union of in of all the successor blocks. Okay, yes or no? So union of, just take the union of like in of B1, union in of B2, union in of B3. For all the successor blocks, you just take the union of in. Okay, very simple. I hope you understood. What about instruction? Is it possible that instruction can have more than one successor? Tell me this simple point. Is it possible that instruction can have more than one successor? Only the last instruction of a basic block can have more than one successor. Do you agree with me? When I say that instruction has more than one successor, that is the last instruction of a basic block. Yes or no? Okay, if a instruction with more than one successor, if you have an instruction with more than one successor, then that will be a last instruction, that will be a last instruction of some basic block. Okay, yes or no? It will be last instruction of some basic block. Only for the last instruction of a basic block you can have more than one successor. Okay, the remaining instructions in a basic block, they have exactly one successor. Okay, so if some instruction has more than one successor, it means this is the last instruction of a basic block. Okay, and remember one more thing. For the last instruction of a basic block, how can you handle it? Let's assume this is the basic block, and in this basic block, this is the last instruction. Okay, tell me how to handle this last instruction. For this last instruction, there are two program points, one immediately after it, one immediately before it. Okay, now you tell me if this instruction, if this IL, this is the last instruction of basic block B, and you can see there might be a possibility that there can be many successors. Okay, yes or no? There can be a successor here, there can be a successor here, there can be a successor here. Okay, for example, this is block B1, this is block B2, this is block B3. Just tell me a simple point, how to handle this instruction. Means what will be out of IL. This is the last instruction of this basic block. IL, when I say IL, this is the last instruction of B. Okay, so tell me what will be out of IL. Remember, because this is the last instruction of basic block B, so I can say that out of IL, that is same as out of B. Okay, and we already know how to handle out of B. Okay, yes or no? Easy peasy. Do you agree? Easy peasy. So you can see that out of IL, that is same as out of B. And we already know what is out of B. Out of B is basically the union of in of all the successor blocks. So you can see in of b1 union in of b2 union in of b3. Okay, do you agree with me? That's it. Okay, so like this you can easily handle. I hope you understood. So you can see this is the conclusion. We have already seen outlive for a basic block or for an instruction. Then how to find the outlive? The formula is very simple. Outlive of n, that is equal to, you take union of in live of all the successors. Okay, very simple. To find the outlive out of n, you just take the union of in of all the successors. All the successors. Very simple. Also, we already know how to calculate in live of an instruction, or also how to calculate in live of a basic block. This formula we already know, that in live of n, that is equal to, from the out live of n, first you remove the kill. First you kill, then you generate. Okay, yes or no? So this we already know. When you have a basic block or when you have a instruction, this formula we already know. Okay, you are already familiar with this formula, that for the whole basic block you can find, let's assume this is the basic block b. So please understand that for this whole basic block you can find what will be def of b. You can find what will be use of b. Okay, and here this is given to you, this out of b, this is given, and we need to calculate this in of b. Okay, so the formula you already know, that is in of b, that is equal to out of b minus def of b. Okay, means first you kill, then union use of b. Okay, so this is the formula. You can apply this formula and you can get your answer. Very simple. So I hope you understood everything we have seen. You can see these notes you can study, because in these notes, in these slides, whatever is written, that we have already seen. Okay, you can see we already know how to calculate in. To calculate in of n, what we will do, from the out of n, first we will remove the kill set. Okay, first we will remove the def, means first we will kill, and then we will take union with use set, or I can say we will generate. So first you kill, in the reverse direction you are going. So from this out live, first you kill and then you generate. So this is how we can calculate in of n. But how do we calculate out of n? Okay, we have already seen how to calculate in of n. Now how to calculate out of n? So for that also we have seen the formula. Okay, you can see, just you can just go through these slides. All these slides, everything that is written in these slides, we have already seen. Okay, you can see, to calculate out, what we will do, we will take union of in of all the successors. Okay, out out of n is equal to union of in of all the successors. Okay, you can see in this diagram, this is a beautiful diagram. Here you can notice that the information is flowing, the liveness analysis, it goes in the backward direction. So you can see initially this sz, when you cross this statement, then what will happen, then s will be killed, and x will be generated. So you can see you will get xz. Okay, similarly you can notice this tz. Okay, and when you cross this statement, then what will happen here, you can notice this t will be killed by this instruction in the reverse direction. First t will be killed, then y will be generated. So you can see yz. Okay, next you can see that for this instruction, or for this basic block, there are two successors, this and this. These are the two successor. So how to find the out of this n? Out of n, how to find? For that we will take the union, xz union yz. So we will get xyz. Then when you cross this statement, then this y will be killed and nothing will be generated. So you can see y will be killed, we will get xz. And when you cross this statement, then you can see x will be killed. Okay, so finally here you will get z only. I hope you understood this point. Okay, very simple. So this is a beautiful diagram. Here you can easily see all the concepts that we have seen. Here you can recall them. Okay, in this example. So remember, these are the two formulas and that's it. Only these two formulas are there in the liveness analysis. In the live variable analysis, only these two formula are there: how to calculate in of n and how to calculate out of n. To calculate in of n, what you will do? From the out of n, first you kill, then you generate. Okay. And how to find out of n? For that you will take the union of in of all the successors. Okay. We have seen these formula with proof. You don't have to by heart. You can logically understand them. You can visualize them. You don't have to by heart, because if you by heart you will forget them. But if you visualize in your mind what is happening, okay, how the liveness analysis is happening in the river direction, how things are happening, as we have seen in this lecture, everything with logic, with proof, with a lot of practice we have seen. Okay, so I hope you have understood these two formulas and all the questions that we have done, all the logic, all the intuition that we have seen. I hope you understood. Now let me tell you one more important thing. See, look at these two formula and let me tell you that in the live variable analysis, only we have these two formula. There is no other formula. But in the gate exam, from these two formula, they can also create a third formula. They can give you that third formula in the option. You can easily notice here. Just make a note of it. See, look at this. In the in live of n, here, this out live of n is there. And already we know that this out live of n is this. So can I replace? Did you notice that this out live, this I can replace with this, then I will get another formula. I hope you understood. So remember, because in this in live of n, in of n, here this out of n is there, and this out of n I can replace with this expression, which is union of in of all the successor blocks. Okay, so if I replace this, then what I'm going to get, you can see this is the formula I will get. Okay, so basically a single formula I will get. You can notice here. And remember one more thing, that this live of n, this is same as in live of n. I told you. Okay, we have already seen this point, that live of n, live at an instruction, that is same as live immediately before that instruction. Okay, so remember, this is same as in live of n. Both are same things. Okay, so you can see in live of n, that is equal to, okay, you can notice what is this? This is out live of n. Okay, so we have replaced this out live of n with union of in live of all the successors. Okay, yes or no? So notice one thing, that here also we are using this live of s, but as I told you, this is same as in live of s. Here also we are using live of n, but actually this is same as in live of n. Because remember, on a instruction there is no program point. The program point will be immediately before it or immediately after it. So when we say that live at some instruction n, it means live immediately before that instruction. Okay, I hope you understood. Very simple. So this is the formula, this is the expression. This also they can give you in the gate exam, in the options they can give you. Okay, and this you can basically derive from the previous two formula. Very simple. Now let's see the liveness analysis, the live variable analysis for CFG without loop and CFG with loop. What is the difference? Actually, there is not much difference. The only difference is that when you have CFG without loop, then you only need to make single pass. In the backward direction, just make a single pass and that's it. You don't have to do multiple passes. This is the benefit. Okay, so remember, when you have a CFG without loop, control flow graph without loop, then to do the liveness analysis, we will go in the backward direction. A single pass is enough. And when we have a CFG with loop, then remember, we will go in the backward direction, but multiple passes we have to make until no change happens. Okay, so you have to make multiple passes in the reverse direction, in the backward direction you will go, and you will make multiple passes until no change happens. Okay, so this is the only difference. So in the gate exam, if they give you CFG without loop, it means you only need to make single pass in the backward direction, that is enough. If they give you CFG with loop, then you need to remember that you may have to make multiple passes until no change happens. In the backward direction, multiple passes you may have to make. Okay, so we will do a lot of practice, but before that, let me give you a tip. This tip we have already seen. When we have a basic block, and for that basic block, if you want to do the liveness analysis, then remember, will you go statement by statement? No, don't go statement by statement, because in a basic block, let's assume there are three statements, four statement, and if you go statement by statement, it will take a lot of time. So this tip says that when you are doing liveness analysis of a control flow graph, then what you will do, in the backward direction you will go. Instead of going statement after statement, you go basic block by basic block. Okay, basic block after basic block. So remember, for the entire basic block, we will find use of b, def of b, and then we will treat the entire basic block as a single statement, like we have already seen before in this lecture. Okay, this tip we have already seen in this lecture. Now let's do a lot of practice. Consider this CFG, this control flow graph. Tell me, does it have loop? You can see there is no loop here in this control flow graph. Now let's do the liveness analysis for this control flow graph. I told you that when you have CFG without loops, then single pass is enough in the river direction. Just go in the river direction, a single pass is enough. You can see this is the initial situation given to us, that initially at the end x comma y, these are live. Can you tell me why it might happen? Anyone want to tell me? At the end, you can see this is the control flow graph. At the end, is it possible that at the end some variables are alive? These variables are alive. It simply means that they are used somewhere. Yes or no? So tell me, where are they used? I am saying at the exit in this control flow graph, at the exit, this x comma y, these are alive. So where are they used? Maybe in other functions. Remember, I told you that in a program, if you have 10 functions, then we make 10 control flow graph. Every function has a control flow graph. Okay, so remember, maybe there is some function where these variables are being used. Are you getting my point? So please understand that in this control flow graph, at the exit node, these variables are live. Maybe the reason is that these are used in some other function. Okay, because for every function there is a control flow graph. This control flow graph we make for a particular function. If there are 10 functions, then there will be 10 control flow graph. Okay, now let's solve it. So you can see this information is given to us, and we will do the backward analysis. So let's do this. Okay, now remember, here you can notice we have two statement in this basic block. Okay, so you can see, should I go instruction by instruction? Will you do that? Will you do that? That to analyze this basic block, will you go instruction by instruction, first this, then this? Will you do that? Don't do that. If you want, you can do that, but that will be time taking. Let me tell you a very efficient method. Okay, you will love it. So let me tell you the efficient method. You can see, for every basic block, you just find what are the def and what are the use. That's it. Okay, so remember, we have these basic block. Let me start from the beginning. So in the beginning, there is a basic block. Just tell me what are the use and what are the kill. What are the use and what are the kill? Tell me. Look at the first basic block and tell me which variables are used and which variables are killed by this block B1, B2, B3, B4. Okay, so tell me. You can see here that C comma D, these are used, and B comma E, these are killed. Yes or no? So remember, C comma D, these are used. And what are killed? B comma E. Okay, you can see B comma E, these are defined, and notice C comma D, they are used before they are defined. You can see, okay, they are used. If you are standing here, then you can see that C comma D are used. Very simple. Now, what about the next basic block B2? So this is your B1. That's it. Now this is what we will use. Now we don't have to worry about two statement, three statement, four statement. Okay, this is all we need. Okay, so tell me about B2. What about B2? What are the used variables and what are the killed variables? So tell me. Here you can see in this B2, you can see that C comma D, they are used. You can notice B is also used. B is used before it is defined. So you can notice that C, D, B, they are used. Okay, C, D, B. And which variables are killed? X comma A. These are defined. X comma A. Okay, that's it. This is what I need. I don't need anything else. In B3 also, you tell me which variables I have used and which variables I have defined or killed. So tell me, you can see in this B3, A comma B are used and Y is defined. Okay, yes or no? A comma B and here Y. Okay. What about the next? For this basic block B4, you can see which variables are used. You can see that A comma B are used, C comma D are also used. Okay, and X, Y they are defined. So remember here what are used and what are defined. So let me tell you that you can see A, B, C, D they are used and X, Y they are defined. You can see X, Y are defined, A, B, C, D are used. Okay, that's it. This is all I need. Okay, and you can make the arrow. So you can see this. These are the successors of B1, B2, B3. These are the successors of B1. B2 has only one successor. B3 has only one successor. Okay, so like this. And you can easily see the question has already given to you that X, Y, these are out of B4. Yes or no? I can say that these will be out of B4. Out of B4. That will be X comma Y. Okay, very simple. Now you tell me, we have out of B4 that is X comma Y. Here, here we have X comma Y. Now let me know. When you pass, you will go in the reverse direction. When you pass block B4, then tell me what will be in of B4. Let me know what I will get here. In of B4. In of B4. What that will be? That is very simple. First you kill, then you generate. Yes or no? So remember, first you kill X comma Y because you can see in this block B4, X comma Y, these are killed, or I can say these are defined. So you can see that from this out of B4, first you will kill. So okay, so kill X comma Y. Then you generate A, B, C, D. So remember finally what I got? A, B, C, D. Okay, yes or no? So remember, that's it. This is what I got. A, B, C, D. Okay. And you can notice that for this block B2, there is only one successor, that is B4. For this block B3, there is only one successor, that is B4. So because there is only one successor, so what is out of B3? That is same as in of B4. And similarly, what is out of B2? That is same as in of B4. Okay, yes or no? Very easy. So now tell me, what will be this out of B3? Out of B3 is same as in of B4, A, B, C, D. Similarly here, A, B, C, D. Okay, isn't it simple? Very simple. All the concepts that we have seen, we are just using them, nothing else. Okay, and remember, every basic block we are treating like a single statement. We don't have to go statement by statement. We can go basic block after basic block. Okay, now you tell me, when you cross this basic block in the reverse direction, when you cross this basic block, then what we will get? You can see first you will kill, then you will use. Okay, so first you kill X comma A, you kill them. So you can see A will be killed. Now you got BCD. And now you generate BCD, BCD, BCD union BCD, that will be BCD. So we got BCD here. Okay, tell me about this one. Go in the reverse direction. So you can see first you kill Y. Okay, when you cross this B3 in the reverse direction, then first you kill Y. There is no Y here. Then you generate AB. So ABCD union AB, that will be ABCD. Okay, that's it. Now you notice here, this basic block B1 has two successor. Yes or no? So tell me what is out of B1? What that will be? That will be union of in of B2, in of B2 union in of B3. Okay, yes or no? Because remember, this block, this basic block B1 has two successor. So the out of B1, that will be equal to union of in of all the successor basic blocks. Okay, so you can see what we will get here. we will get ABCD union BCD. So we got ABCD. Okay. And finally, tell me what will be in of B1. That will be what? In of B1. That is very simple. From this ABCD, first you kill B comma E. Okay, first you kill B comma E, you got ACD. Now you generate CD. Okay, so ACD union CD, that will be ACD. So that's it. This is your answer. I hope you understood. So remember, finally, in of B1 that is equal to ACD. Okay, ACD. So I hope you loved this analysis, because remember here we are not going instruction by instruction. We are going basic block after basic block. Okay, and here you can see this control flow graph. This has no loop. Okay, yes or no? This is without loop. This is CFG without loop. So in the backward direction, one single pass is enough. Okay, very simple. I hope you understood. And remember one more thing, that every basic block you can treat like a single statement. For every basic block, you find what are the used variables and what are the killed variables. Okay, and then you can easily solve the question. It will not take much time. Okay, the concepts that we have already seen, we are just using those concepts. So you can see this will be your final answer. I hope you understood. Let's solve this question. In this question also we have a CFG without loop. You can notice that there is no loop in this CFG. And notice one more thing, that at the end nothing is given, like which variables are alive at the end, that is not given. So what we will assume, we will assume that at the end no variable is alive. Okay, yes or no? This is what we will assume. Now you tell me what we need to do. I told you that don't go statement by statement. Every basic block you treat like a single statement. Okay, yes or no? So I can say that this is your basic block B1, B2, and this is basic block B3. These are the basic blocks. For every basic block, you find what are the use and what are the def set. Okay, so let's see here. Let me find for B1. Okay, for the basic block B1, what are the what is the use set and what is the kill set? Kill means def. So you can see the kill set is very simple. That is B is defined, and you can see that C comma D, these are used. Okay, so you can see C comma D are used. Okay, next you can see this B2. For this B2 also the same thing you can do. What are the used variables and what are the killed variables? So tell me, for this B2 you can see the used variables are B comma C and the killed variable is A. Then we have B3. Then we have this B3, basic block B3. In this basic block B3, you can see the defined variables. These are X comma Y. Okay, so you can see def, that is X comma Y. And you can see which variables are used before they are defined. So that is ABCD. Okay, ABCD. So you can see use, or I can say generate, that is ABCD. That's it, very simple. And remember, already it is given that at the exit of B3, there is no variable alive. Okay, this is already given to you. Means this is out of B3. Okay, this is given. Very simple. Okay, that's it. And you can see these are the edges, that there is a edge here, there is a edge here, and there is a edge here. Okay, now let's do the analysis. So we will go in the backward direction. Single pass is enough because this is a CFG without loop. Okay, so tell me what will be in of B3? Let me know. I am asking what is in of B3. How to find in of B3? That is very simple. From this out of B3, first you remove this def. Means first you kill, then you generate. Okay, so you can see from this 5, if I remove X comma Y, I will get 5. Then I will generate. Now ABCD will be generated. Okay, ABCD. So remember the in of B3, that is ABCD. Very simple. Okay, now tell me What about this b2? You can see for this b2 there is only one successor. Okay, for this b2 there is only one successor, that is b3. So remember, this out of b2, that is same as what? That is same as in of b3. Okay, because there is only one successor. Very simple. So remember, here also you got a b c d. Okay, and remember that for this basic block b1, actually there are two successors. So first, before finding this out of b1, you need to find in of b2 also. Okay, so let's find what is the in of b2. What will be in of b2? That is very simple. From this out of b2, you first kill, so a will be killed. Then you generate bc, so bcd union bc, that will be bcd. Okay, that's it. Now you can notice for this basic block b1, there are two successors. So remember, what will be out of b1? That will be union of in of all the successors. So I can say that in of b2 union in of b3. Okay, so you can see what I will get out of b1. What I will get out of b1, that will be bcd union abcd. I will get abcd. Okay, and finally, what will be in of b1? That will be equal to, first you kill, so b will be killed, and then you generate cd, so I will get acd. Okay, that's it. So this is the complete analysis for this cfg without loop. I hope you understood. Very simple. So this is enough for this lecture. In this lecture, we have seen liveness analysis for individual statements, for basic blocks, for control flow graph. And in the next lecture, we will discuss control flow graphs with loops also. Basically, the concept is very same. The concept is same. We will go in the backward direction, but we sometimes we may need to do the multiple passes until no changes happen. Okay, so basically in the next session we are going to solve a lot of questions based on cfg with loops. Also, we will solve all the gate pyqs also in the next lecture. Let me tell you, all the concepts related to liveness analysis, live variable analysis, all the concepts we have seen in this lecture. A lot of practice we have done in this lecture. In the next lecture, these cfg with loops, these questions we will do, gate pyqs we will do, and also the applications of live variable analysis. These we will study in the next lecture. Okay, thank you everyone. Please share your feedback. I hope you loved this session. Please put a comment. Thank you.